Just 1 second. Let me share screen. Okay. Can you see my screen?
Yeah, we can see your screen, but I think your audio is a bit messed up.
Let's try now. Is it better now?
Yeah, it's better, but maybe a bit more volume.
What about now? It's fine now?
Yeah, now it's okay. Yeah.
Okay, cool.
Yeah, cool. Yeah.
Yeah.
Okay, so are we good to start? We'll just have a short intro of yours.
Mm-hmm.
Okay. Yeah.
Okay.
So good morning. Good morning to all. So today the first session is by Edgar Riba. He's from Spain, Barcelona. So he's a computer vision researcher at Grid.ai, and he's the founder and creator of the open source library Cornea. So he's also a PhD scholar in the field of computer vision and research engineer, and recently he was also associated with Grid.ai as a research scientist from March 2021. So he has got a lot of experience with AI, machine learning, and especially the various Python libraries. So Edgar, we are really glad to have you here for the Open Source Summit India. And the stage is all yours, and we are all ears. Thank you.
Okay. Yeah, thank you, Jacob, for the introduction.
Edgar, I think your video is not on.
Okay, just 1 second. Yeah. No.
Perfect. We can see you now. Yeah. Perfect.
Yeah. Cool. Yeah. So thank you, Jacob, for inviting me to attend to this talk and the whole organization. So I've been following these days the whole advertisement. I think you did a great job. So it's a good event, definitely. Yeah. So the talk from today, well, it's titled Open Source Differentiable Computer Vision for Modern Deep Learning, which will be more or less an introduction to Cornea. I'm going to explain now what's Cornea and OpenCV. So I guess people aware about computer vision know about OpenCV, and I will explain more or less the relation between Cornea and OpenCV. Yeah, and as anything that I can add to the introduction. So I'm Edgar. I'm a computer vision researcher. I'm the creator of Cornea library, and I'm also part of the OpenCV technical committee. So I attend time to time to those meetings to discuss about the roadmaps about OpenCV. Okay, so first of all, before starting, for those that are not aware about what's really computer vision, so basically computer vision, it's about having a high level understanding from digital images. And basically the idea that I want to transmit here is that, you know, that from any device, it can be a smartphone, cameras, we get some data, which basically it's not more than a matrix. That's what I like to say all the time. So basically, from real life, we can get digital data. Then later, from computer vision perspective, we analyze and then we get some high-level information. So that's the main idea of what's computer vision. Then, in terms of libraries and ecosystems, so you know that the ecosystem is quite diverse. So there are a lot of frameworks implementing computer vision, different languages or technologies like Python, C++. Now it's probably you heard a lot about NVIDIA CUDA to accelerate processes, or more different approaches using like OpenCL, and then the emerge of these deep learning technologies like PyTorch, TensorFlow, or intermediate representations like OpenNX. But then in terms of actual libraries, there are, for a long time, we have been using, for example, OpenCV, and now it's 20 years old. But also at the same time, there are other small libraries or frameworks that implement computer vision techniques, like MATLAB or Saintgits, or maybe if you heard about VLFit. But in this talk, I'm going to focus on OpenCV, which is probably the most known library for computer vision. So just a short description about the different things that you can find in OpenCV. For example, in OpenCV, we have algorithms for image processing, transformation, or different techniques for optical flow segmentation, 3D like calibration, SLAM, HVD. And now we have different modules for also deep learning. So the OpenCV community, it's let's say quite huge. So it's a very, very known repository on GitHub. It has over than 50K stars, crazy number of downloads per week. And it's been used for a lot of part of the industry. So yeah, as the main advantages of OpenCV is that, as I said, it has a huge community. It's really, really used in real world applications. There are contributors from like big companies, Facebook, Google, Amazon, and I guess a lot of companies that I miss here. But in the end, it's a project that has been there for 20 years. And apart from that, it's OpenCV. It's not only the framework, but it's about the community. So there are right now different initiatives like different courseware. There is like a very active blog and a series of small projects like this new OAK camera that implements directly in embedded devices. So yeah, just to have an idea that OpenCV right now it's not the library, but instead it's like the complete community. But something that happened last year, so you know that with all this deep learning hype, OpenCV has been kind of not deprecated, but it had some problems with all these deep learning technologies. So the main reason is that from the very beginning, so OpenCV was created. I mean, we had different not deep learning, but machine learning technologies, but it was not really designed for those technologies. So basically, OpenCV works with 2D images. So it's not supporting properly tensors, which is basically the main backbone technology under these new technologies, like it could be PyTorch or TensorFlow. So this is one of the main kind of blockers right now for OpenCV in front of deep learning. And here is where we came. So myself and Gary Brasky, the founder of OpenCV. So while I was doing my internship at one of his companies, so we started a small project, a small package for geometry, and then we had this, well, we asked to ourselves this question, what is traditional computer vision inside the deep learning area? And yeah, we realized that there was this black hole area. So at the point that PyTorch started to be more used, there was no library at all implementing all these traditional computer vision algorithms in PyTorch. And Yeah, so and this the result of the answer of this question in the end was Cornea. So Cornea is an open source differentiable computer vision library for PyTorch. So this is the the first stone that we put to this path, how to start going from very classical computer vision algorithms found in OpenCV and start to migrate more to be more, let's say, related to the modern deep learning frameworks. So basically, yeah, Cornea is a differentiable vision library built on top of PyTorch, and it's a re-implementation of some parts or the OpenCV functionality in terms of differentiable tensors. So in the end, we follow more or less the same principle of as OpenCV itself. So it's we try to have a very accurate set of vision algorithms in order, as I said, as I was mentioning before, to keep the computer vision community very tight. So yeah, so as the different features that we cover in Cornea, so basically, yeah, we implement a lot of classical vision algorithms that now are differentiable, and we take off all of the properties from PyTorch, like we have a transparent API to implement with different devices like CPUs, GPUs. Now we support also TPUs, the parallel programming, meaning that everything is implemented using the different accelerators from PyTorch, like CUDA. So everything is done by PyTorch. So in Cornea, we have just a very high-level interface that you don't have to care about those things. The same for the distribute API. You can define your algorithm and then send it to clouds or to distribute systems. And now also it's very handy for production using the Torch script compiler. Then in terms of functionalities, so we cover different aspects from computer vision. We implement different routines for data augmentation, transformations, color, geometry. Then also we have different algorithms for feature detection, edge detection, and 3D geometry. So let me show you some examples about that. So for data augmentation, we have a module that implements differentiable functionalities for the augmentation techniques for 2D and 3D vision. They are all batch, able to be used with CPU GPUs. We can return and change transformations. So you can see here how you can do the data augmentation with also metadata, with mask, key points, and bounding boxes. And then for image enhancement, so we implement different techniques for normalizing compute histograms and images, also in 3D images, and different routines, yeah, to just different properties basically from the images. Then for color conversions, different algorithms to convert forth and back from RGB to grayscale, then different fancy color representations. So we are starting now to increase more the different algorithms here. So you know that you can represent images in many different color spaces. So yeah, we would like here to have in the end, as in original OpenCV, the whole set. And then yeah, we have a strong module for feature detection. So yeah, we implement different techniques right now, state of the art for deep learning, local feature detections. You know, like SIF features. So these techniques are very used for example, for image stitching or even for robotics for SLAM applications. So we implement here all the different functionalities and models to perform all these compute all these features. Then we have an API for filtering. We implement different techniques for filtering. We provide different kernels for the filtering. This is very related to the edge detection. So we implement the different functionalities to compute edges on images. Here you can see one example for canny edges, which is a very known classical algorithms for edge detection. Then in terms of transformation, so as I said before, Cornea started as a small package for geometrical transformations. So right now in Cornea, or geometry package, I would say that it's the most robust and more full of different implementations for the geometry part. So we cover implementations for applying affine transformation to images, doing crop, resizing, flips. Then we have a low-level API to warp based on different geometric transformations like affine transformations, homographies, or in case you work with a 3D with rotational translation matrices. Then in terms of 3D geometry, yeah, we implement different interfaces to interact with perspective camera. We introduced recently, it's not here, but we introduced this stereo camera API. So we implement also different routines to work with geometry, epipolar geometry, which is basically all the functionality that is used for to solve structure from motion problems. And then we have all this set of operations to compare between different angle transform representations like quaternions and rotation matrices. And finally, different functionalities also to work with depth images from RGBD cameras. So in terms of community, so right now the Cornea project, so it has been well adopted by the community from the very beginning. I guess for the fact that I was explaining before that since PyTorch started, we had the Torch Vision that was implementing some deep learning models and then some transformation. But at that point, there was no actual library implementing all these classical things, computer vision things that even that with the deep learning, I mean, it's not that deep learning has overtaken some of the classical algorithms, but still in the industry, some of the classical algorithms are still used. So, and this is why I think that's the reason about the success of Cornea. So we have now a very active community with over of 4,000 stars in GitHub, more than 400 forks, more than 100 contributors. Of course, we are open source. We kept the same license as OpenCV and Apache 2. Oops. So in terms of development, in order to start using Cornea, so we have a golden rule in Cornea. So we are dependency free, meaning that we only need Python as a requirement. So basically in Cornea, we implement everything from scratch using Python. So we don't have external dependencies. And it's something that in the end, it's very handy when you want to install Cornea, that you just need to install with pip. So pip install Cornea, and then you will get your latest release of Cornea, and then eventually it will download the neat version of PyTorch. So then if you want to learn a bit more about Cornea, so we have now a new website, so feel free to go there, cornea.org. we are now starting to increase our ecosystem. We have been integrated in different frameworks like Line Flash. You can also use directly Cornea in Kaggle kernels. So in case you are attending to Kaggle competitions, you don't need to care about installing Cornea, so it's there. Frameworks, other training frameworks like Catalyst or Fossasia, and then several toolkits for machine learning are starting to adopt us. Then, yeah, so also feel free if you want to learn about our processes. So we basically live in GitHub, so feel free to go there. We have also documentation there that we are trying to keep updated. So we recently revamped our online documentation. So our documentation it's based on different open source libraries like Sphinx. So we auto-generate the documentation each time that we merge a pull request. So we generate all these from the source code. We include, we auto-generate examples, visual examples, to show more or less what's happening in the different algorithms. And then we have also this tutorials website where you can go, and then all our tutorials are rendered in HTML, but also we provide the live version using Colab. So you can try each of the tutorials and then start playing with parameters, change your images, or even compare to other libraries. Then in terms of what are the next steps, so we are planning to include more different algorithms from classical vision, like this connected components algorithm, which is a very known algorithm for detecting like small objects or even segmenting. And also we're planning to grow more, for example, we're planning also to grow more for applications like farming, implementing optical flow, SLAM, or camera calibration APIs. We also are planning to implement similar to OpenCV, that we have to have an interface for camera or embedded devices. And then yeah, so robotics, it's another like big milestone here. So you know that there is ROS, this robot operating system, which is more or less the standard for robotics right now in the open source community, which from the very beginning, OpenCV has been like the default package for vision. So the aim here now it's to be the default package for Rosto, which is also the next generation of ROS. Then let me go to very quickly to different examples to show you more or less how Cornea looks like and how combine. So basically here in this example, you see that you can still use OpenCV like, and then you have different functionalities to convert to those tensors and then apply directly like color, as I mentioned before, color conversion, like to change from VGR to RGB, normalize the image. So you see that very quickly you can start using Cornea, in this case with OpenCV. Another example is for data augmentation. So here we show how you can easily also use Cornea to implement, like, not a very detailed here, but this is just a small example for defining a class that will implement some different transformation on the color intensity, you will apply also random affine transformation to images, like a different rotation, translation, scaling, and everything. You can encapsulate everything inside an NN module, which is more or less the basic data structure for PyTorch in order to stack different operators. Then more fancy transformations that we recently applied is to apply into images, like to cut the images in a grid and then apply independently different transformations to each of the patches in the image. So this comes from a recent paper that we found that were implementing Cornea, and yeah, I think in particular I really like this transformation. And I think that in terms of also research, it's very interesting, the things that you can do using things like Cornea. Yeah, so also local features. So for example, you know that OpenCV has been like the reference for feature detections, like for the shift operator, which takes saliency points from images. You get your descriptor. But then in Cornea, we have kind of upgraded this set of different local features, and we included more recent state-of-the-art. One of them is one feature descriptor called Harnet, which is completely based on deep learning models. And you can see that, this is one of these fields, local features that definitely deep learning improve a lot the quality of the results. You see here that when you try to match using the different techniques, you see that, for example, using deep learning here, you can get way more number of correspondences between these two different images. Then we have include Cornea as part of this CVPR challenge for image matching. So yeah, so we tried, one of our ideas is to try to integrate Cornea in this sort of challenges in order to be updated with different state-of-the-art methods. So in this case, for the case of local features, based on the more or less results of these challenges, it's how we decide which methods or we believe that can be included to our main repository. Another example is using morphology. So yeah, so morphological operator, it's another like a small area in computer vision where you can take one image and then applying different kernels, you can achieve, as you can see here, different results. And I think that, using this kind of techniques, and even right now with Cornea, you can get like really good looking results. So okay, so in terms of research, so we try to keep also an eye also in the different papers from the big conferences that implement Cornea. So myself and Dimitro, which is my colleague leading the project, we are very active in Twitter. So if you have the time, just try to follow us, and we try every week to share all the papers that are implementing Cornea. So here it's just one example of a paper that is using, for example, the data augmentation API from Cornea to more or less automatically create this data augmentation during the training of the networks. Another example for research that we found recently, and it's very interesting, is that they use some of the cornea algorithms, for example, for detecting corners. They call it here stable key points. So they use, in that case, I believe was the Harris corner detector, which is one of the most classical corner detection algorithms. And since we have it in cornea as a differentiable layer, this means that you can include this operator inside the network, and then using that operator, you can backpropagate through the whole network, and then you can optimize the whole parameters of your model. And this is, I think, a really cool example why and how you can use differentiable operators inside modern deep learning frameworks. Yeah, so this is the same, just some results. Yeah, yes, I mentioned here they were using the cornea detection. And with this, this events camera, which is a new, some sort of technology around cameras. So you know that originally cameras, you can get the RGB. There is now this technology with event cameras that more or less produce this edge detection from real images. Also for teaching, so similar of OpenCV, so we are now starting to create different tutorials and courses. So in that case, Dimitro, so he's associate professor at the Prague University. So he created a whole computer vision a course for low-level techniques implementing computer vision using cornea and PyTorch. This is just one example with the method that I was mentioning in the paper before, this Harris corner detection, where you get, as you can see here, this input image, which is a very simple structure, and using in that case the Harris corner with an extra operator, you can get the different places or the corner locations. More examples of the same idea. Yeah, I think that's everything from my side. So yeah, as I mentioned, yeah, if you want to start to be or learn more about computer vision or cornea, yeah, feel free to join our Slack. We are quite active there. Recently, a lot of new contributors from industry, academia are joining. So I would say that we have right now a very nice atmosphere in Slack. So a lot of people is asking questions, other responding. So yeah, I will encourage everyone that wants to learn more about computer vision that join us. Yeah, and as I mentioned, feel free to follow on Twitter. I think, well, I would say that we are quite active there. So we try to more or less every day tweet about not only about implementations of paper, but also we share different tutorials or different articles related to computer vision. Yeah, so that's it from my side. I guess now it's time for questions. I don't know, Jacob, how this will work for questions.
Yeah, Edgar, can you hear me?
Yeah.
Yeah, yeah, so participants can unmute yourself and ask questions. So I think we've got some questions. Does cornea have neural style transform models?
Not yet. Yeah, so The main idea, so yeah, probably I can give a bit of context here. So the answer is no, but let me explain why. So basically, we started Cornea, as I said, as a small project for geometrical transformations, trying to implement very classical algorithms for vision. So, and yeah, a neural style algorithm is something that came, let's say, after all this deep learning hype. Yeah, right now, yeah, it's good to know that, yeah, to get these questions so that we can put in our backlog. So, to see in the future if we can implement. Yeah. But definitely, now that you mentioned that, there is a package called Pastiche. I can share it here. Let me write it down. Pastiche, that is implementing this kind of techniques. And which the main author of this package is a Cornea contributor, and he's also part of the PyTorch team. Yeah, so if you want to work with this kind of techniques, yeah, feel free to use this package.
Yeah, we've got another question, sir. So it is a challenge to generate synthetic images from medical images for many reasons, shortage of relevant images, etc. So is there anything that Cornea offers for supporting generation using GAN? Also, can we use Cornea with TensorFlow?
Yeah, so yeah, I think this is a good question. So we don't provide directly any implementation for GANs, but now that you mentioned here about yeah, medical imaging, so yeah, we are starting to grow on that area. But also, I think that for GANs, which is now very related to unsupervised learning, I think that Cornea has still a lot of potential here in this area. The reason is basically our augmentation API, which is it's not a common augmentation API. Basically, our augmentations API is differentiable. So this means that you can plug any augmentation operator from Cornea, and then this can be included inside as an extra operator to the neural network in terms of training, and this means that you can use to optimize also the parameters of the transformations for each of the augmentations. And I think this is actually this is my kind of area of research right now. Differential augmentation, which I think it's yeah, it's a very promising field in the areas like unsupervised learning. So yes, we don't implement directly GANs, but we provide all the tools, like in this case the differential augmentations, to work directly with GANs. And also to mention, so we're starting now to include more like deep learning models, but our original idea actually was not to include any deep learning model, because you know that for a library, it's you know that now in deep learning, possibly every week you can find a new model, for example, for object detection or segmentation. Every week you find a paper that is implementing a new model. And in terms of library, this is, I mean, kind of impossible to scale it and maintain it. So we have this rule that we try to be very conservative here in terms of implementing deep learning models. So we want to be like the reference of having curated methods. So that's more or less our philosophy here.
Thanks, Edgar. I hope you have time for maybe one or two more questions, if you don't mind.
Mm-hmm.
Yeah. So by having Cornea in the end-to-end deep learning pipeline, is it possible to learn the different parameters of the CV algorithm?
Yeah, definitely. Yeah, this is actually the main idea of Cornea and why we re-implemented some of the classical algorithms from OpenCV now with differentiable tensors. So yeah, the main idea is a bit related to my previous answer, is that all our operators are differentiable. So this means that any input that you put there can be an optimizable parameter that can be included in the optimization loop during the training of a neural network. So, for example, the example I was showing before with the Harris corner detection. So Harris, so you give an input and then you get some results, but there are some parameters there that eventually you can pass it as a differentiable tensor, and all those parameters can be included um, um, during the optimization process. So yes, the answer is definitely yes, and actually it's the main reason to exist of the Cornea library. Yeah.
Yeah, Edgar, so we as researchers, and I know that there are many people who are researching in AI currently attending this session. So we've been using PyTorch, OpenCV, Columnar. So we are using open source libraries and one is Columnar. So being a one who has developed the library and being a one who's using the library is entirely different. So what would be like your suggestion or your ideas on rather than being users of these libraries, what is the initial step that as researchers we should have to like try to create our own libraries, try to contribute to the open source ecosystem?
Okay, so if I got well the question, so you were asking more or less what's the starting, what would be the starting point for.
What is the real motivation, the initial step that we should take?
Yeah. So yeah, as I mentioned, yeah. Well, in general, in open source, so the first step is as an individual, try to figure out what are your motivations. Okay, that's the first step, and I will say here my tip. It's yeah, contributing to open source. It's good for everyone, meaning that you can learn yourself and in the end you can get like you know free curriculum with that, right? So that's the first thing. The second thing is okay, once you have figured out more or less what are your motivations, then try to find a project. So, and as you probably know, yeah, all the open source right now more or less happens in GitHub. So let's then what I would suggest is go to GitHub, go to a project, and then start digging to, for example, the different issues, and more or less try to track down what are the needed things, because in general, projects that are more or less active or well structured, in GitHub, you can find the different issues with different labels. For example, in Cornea, and I think right now by default it's done by GitHub. They provide this good first start issue or something like that. So I would recommend here to go to the different issues and try to see something that you believe that you can start working on. And then in the end, yeah, in GitHub right now it's some sort of a social network. So I think it's very simple, no, to create an account, and then eventually you can start asking questions. And then also some projects like us, but I think right now it's very common to have like separated threads for discussion like Slack. I would recommend that also to join these communities and start to interact with the project maintainers or the core contributors, so that yeah, you can start easily to contribute to the project. That's what more or less I would say are the first steps to start contributing to projects like Cornea. I'm not sure if I answered your question.
Yeah, thanks, Edgar. So I think there are no more questions from the audience. Yeah. So Edgar, it was a pleasure having you for Open Source Summit in 2021. So I hope we'll be having future collaborations also. Thank you so much. Enjoy your day. Bye. Thank you.
Okay. Yeah. Yeah. Thank you so much for inviting me to give this talk. Yeah, I think it's attending to these events. It's always a pleasure. Thank you.
Thanks. Rohini, can you hear me?
Yes, I can hear you. Wow, it actually has a background. Let me remove this background.
So I think we are good to start, right?
I will have a background. Sorry for that.
Yeah.
I think this should be okay.
Yeah. So the next session is by Rohini Bhavangar. She is a senior developer advocate at Amazon Web Services. She brings over a decade of experience in the IT industry, primarily focusing on cloud computing technologies. With AWS since Jan 2014, she has worked on multiple roles, including being a solutions architect in Asia and India. As a senior advocate, she has focused on the need for cloud native customers and is actively involved in the DevOps and container space. She has been leading conversations with business of all industries and cycles on innovation as they deploy critical workloads onto the cloud. She is passionate to share her experiences on building architectures with best practices and help strengthen builders of tomorrow. Rohini frequently speaks at conferences, community meetups, online events, and related channels. So over to Rohini. The stage is all yours, and you're all yours.
Thank you so much. Just confirm you can hear me well and you can see my screen.
Yeah, perfect.
Awesome. Thank you so much for the invite, and thank you everyone for joining. My name is Rohini, and you have really tried to give a nice introduction about myself. So I'm going to talk about infrastructure as code. I mean, we all know mostly about infrastructure as code when it comes to cloud computing in general, but today we are going to talk about infrastructure is code, how your infrastructure can be part of your code itself with an open source tool called as AWS Cloud Development Kit. Before that, I do want to introduce myself. I want to learn more about you in the audience so I can, pivot my presentation to suit most of you in the audience itself. So yes, I've been with AWS for last 7.5 years, and I've done multiple roles. I've been a support engineer where I used to focus a lot on CloudFormation, which is one of our AWS infrastructure as code service. I've been a solutions architect for almost 5 years. Before that, I used to be a Java developer. And then I pivoted into a more DevOps related role as I was working in my previous company, and that's me. So just last year around this time, I moved into this role, which is more like a tech evangelist, but we call it as a developer advocate. And my work is to work with a lot of community to help them to make tech simple. That's what I want to talk, and make tech simple and make it easy. So that is my goal of doing these sessions with you. So before I proceed, I do want to get a little bit more insights from you. So I would request everyone to just go to slido.com and you can enter this pin code there. I have few questions for you there. So just go to slido.com and enter this this code at slido.com. Let me know if you have any issues going there. Just go to slido.com. I'll also add it in the chat. I have like 3 questions, I promise. Not more than that, and I have very simple questions. I'm just going to start the poll. So the first question is, how long have you been in the industry? I do want to know how long some of you have been in the industry. It's fine this for me to understand who am I talking to. Thank you for whoever has, the one person who has given the input. I'll just wait on the slide for few seconds until I proceed. I see lots of hundreds of you there. So hopefully I'll get some 10 to 20 at least. So I have a little bit of quorum to understand who is in the audience. So that's the first question. the second question is, what role best describes you? Like, who are you? Are you, of course, you're a student, but you could also be interested in development. You could also be interested in something like testing or machine learning or something like that. So please do give multiple ticks wherever possible so that I understand majority of you where you fit into. And the last poll is obviously about level of AWS usage. So I do want to know if you all are new to AWS, so then I can pivot my talk accordingly, or if you're just exploring AWS or have never looked at AWS, I will also try and give some pointers for that. So you can see the live counter is moving, and I see a lot of you don't use AWS, so I will try to also add that input in there. And I'll just keep this poll open. I'm just going to look at some of the data. So most of you are students, so that is amazing. A lot of you are students or researchers, awesome. And most of you also call yourself developers, which is my crowd for the talk. So thank you. And okay, so a lot of you don't use AWS today or have started using AWS, right? So let me try to make it a bit simple for all of you if you are getting into AWS. I do want to make sure that you get a little bit insights into AWS, so you would want to work with AWS, because I do work with AWS, so I love this technology. So where is my slide? I lost my slide. Okay, that's my slide. Sorry for that. You can keep giving in your inputs. There is another screen where I'm looking at those. So let's get started. I do have an hour. So before I get started, we do a lot of open source at Amazon, at AWS. If you're interested at Amazon, you can just go to this link where you can find more projects on open source at Amazon. But these are some of the open source projects at AWS. So we have our own distribution for EKS. EKS is our Kubernetes managed service. So we have a certified Kubernetes distribution for that. We have our own open source operating system that is Linux based, and it's actually meant for containers. Okay, we also have a lot of different projects on the AWS platform, which are sometimes more mainframe main services that we provide to a lot of our customers. So you can find a lot of these are just some of them highlighted, but there are a lot of other projects that AWS has as open source on the AWS platform. We even work with a lot of open source projects and pick them up and make them into a managed service on the AWS platform. Like we have a Kubernetes managed service on the platform. So you don't have to worry about how do I set up the master, how do I have a failover and HA and everything for the master. You use this service and you just work with that service to create a Kubernetes environment. So that's just a little bit about open source at AWS. Today, we are going to talk about CDK. Now, CDK has 3 different formats. The one we are going to talk about is CloudFormation and Kubernetes. If you are someone who is interested in Terraform or want to work with Terraform in the future, please do stick by, because there are a few differences. Like there could be some command line difference here and there, or the format that it outputs. But otherwise, these are on the similar path. So you would learn something out of this session with respect to CloudFormation. With respect to CDK. Okay. So we are talking about CloudFormation and Kubernetes. CDK supports a lot of languages like TypeScript, JavaScript, C#, Java, Python, and there's also a roadmap for Go. And CDK, obviously, for something that is for Kubernetes, and Kubernetes anywhere, okay, not just AWS, anywhere. So if you're a person who would love to work with Kubernetes, work with containers, and want to work with CDK, this is something for you. And Terraform, both Terraform and Kubernetes formats are in alpha stage. They were launched sometime early last year. So they are still in alpha stage. So that's about what CDK is. We will cover a little bit in depth about what is CDK, why do you need it, how do you work with this cloud development kit, and we will also look at demo for both of them. We'll spend a bit more time in the demo rather than in the slides, but I do want the slides to help you understand why we need CDK. And lastly, I'll also give you some information as to how you can learn about CDK or the open source projects at AWS, how you can contribute, how you can also learn about AWS in general if you are interested to learn about the cloud computing platform. So evolution of infrastructure provisioning in cloud. Before we go into cloud, right, I started working on cloud computing technologies somewhere around 2009, 2010. But then, even then, for us in India at least, cloud was still a buzzword. Even it was a buzzword everywhere else as well. AWS was just 2-3 years old. There were a lot of concerns around cloud computing. Then I was doing a research of multiple cloud. Why did cloud computing come into place? It's a term that came new, but cloud computing was there was an evolution of cloud computing for many years. Earlier enterprises, people who had a lot of money to build data centers could build data centers. They could build huge places with data centers and lots of servers, and they could build applications for other people, right? Over the time, what happened is people can't afford, not everyone can afford having a data center, right? So then people started renting data centers. So they would rent maybe a server rack or maybe a floor to people who are interested in building applications that would need such kind of a server farm. When that moved on, then the idea of when internet became a little bit available, internet was a little bit cheaper for all of us to start using. We moved on from that dial-up phase to having proper internet connectivity. Cloud became more evolved, where you can now access cloud, which could be any cloud, but in this case, let's talk about AWS. You can access AWS cloud just over the internet. So I can access these compute like CPU or GPUs, or I need certain storage, like I need certain CPU, I need certain memory, and I need certain storage to run certain applications, right? The base requirement is CPU, storage, memory, and network. That's the 4 base requirements. I can actually access these computers, these virtual machines in someone else's cloud over the internet, right? So you can access these over the internet. And that's what gave the boost for cloud. And that's what gave a boost for a lot of startups. And after cloud came in, we saw a lot of rise in the startup companies, because now startups don't need to have that kind of investment to build their own data centers. They could just access the cloud, create the applications. If it didn't work, just scrap it out and then start with a new idea. And that is the best value proposition for working with cloud computing. And that's why you see a lot of companies have leveraged cloud to build a lot of applications, a lot of new innovative items that have come into market today, right? So that's what led to cloud computing. Now, cloud was all virtual. I didn't have to go to a physical data center and work with it, right? Now, when cloud became more virtual, it became more accessible to people who are dealing in virtual environments. So there was a term called as software-defined data center, right? So cloud became a software-defined data center. Not exactly, but it's on that line, right? So what happened is a lot of operations people started working with cloud, creating that base infrastructure, and developers would only focus on creating or writing code, on writing code itself for that application to sit on the cloud, right? So there were 2 different parties. There was operations and there were developers. But over the time, you may have heard these terms we called as DevOps, where we want to marry both these job roles and say, hey, you're going to do both these roles, and you are going to take the single ownership of the application or the microservice even that you're building, right? You will take ownership of that single application or the microservice that you're building, and you will be hosting that on the cloud platform. So when that started happening, even the way we are creating infrastructure in the cloud, that idea also started having evolution, right? So we will look at that evolution, okay? So evolution of creating infrastructure in the cloud. So initially, whenever you're new to the cloud computing, as most of you are new, like 50% of you are new. So when you will start working with AWS cloud, you will use something called as AWS console. Okay, so it's a management console where you can find a nice GUI where you can click and drop and, do GUI activities with it, and you can create infrastructures. Now, what kind of infrastructure? You can create a base level network, you can create virtual machines, you can create storage, you can create databases, whatever technology you want to use on AWS, you can do that. Now, with AWS, you have a lot of options. You have options. Anyone asks me, hey, I'm a developer, is AWS for me? Or I'm a data engineer, is AWS for me? AWS is for everyone that works in tech industry, because on AWS you'll find services for IoT to machine learning to analytics to DevOps related services. So there are a lot of things you can do, a lot of items you can create on the AWS platform, and those I will be calling as resources. So whenever I say resources, that is anything that you can create on AWS is going to be termed as resources. So how do you create these resources? You start with the AWS Management Console. And this is amazing because it's easy to get started. We all use mobile phones today, like even kids, right? At age of 2, they can easily unlock phones and go to YouTube and watch YouTube, right? The similar way we can easily understand a GUI and we can work with the GUI, right? But what happens is over time, it's easy to get started, but over time, it is not reproducible. If I create a virtual machine with a certain configuration saying this is the operating system, this is the RAM I want, this is the storage I want, blah, blah, blah. If I have to do this again, I will have to, I mean, let's say, take an example. I have a test environment, I have a prod environment. If I create everything in test, I have to again do the same steps in my prod environment. So it is not reproducible. I cannot just copy paste doing that because it's all in the GUI. I have to click, right? Which takes a lot of time. Who has time nowadays? We don't even wait for 5-second advertisements on YouTube, right? Who has time to do this again and again? So then there are people who like to write scripts, and I've written some scripts. These could be your PowerShell scripts, these could be your shell scripts, or these could be any other kind of scripts where you're calling the APIs. It's Amazon Web Services, right? So we expose a lot of web services, we expose a lot of APIs for you to work with these resources. So there is a SDK that AWS provides. You can just call, you can use CLI, you can use the SDK to call these APIs via your scripts. So that's good because now I can add a lot of items. I want to create a virtual machine again and again. I just copy paste that code and I'm done, right? But that also has a lot of problem because you have to still do a lot of boilerplating. You have to do, hey, if something fails, if some resource is already created and there's an error, how do you handle those errors? You have to write a lot of code around that. You have to write a code around race conditions or against configuration drips. Like, hey, my script is written, it's asking to create a resource, but that resource already exists. What do you do in that case? Or the resource has changed over time. How do you make those changes to that resource? How do you update it? So there are a lot of things that you have to take care of. Then the evolution came when CloudFormation or Terraform as services were created. And this was, trust me, this was at least I worked on CloudFormation in 2014. Okay, so CloudFormation did come before that, around 2012 or 13. And the idea behind CloudFormation or Terraform is simple. You don't have to work with the APIs directly. You don't have to call any commands directly. You will write a JSON or a .yaml file. Okay, so there are two kinds of files that are generally supported, which is YAML or a JSON file. So you write these JSON files. So you as a user write this JSON file, and you give that JSON file to these services. You give it to CloudFormation or you give it to Terraform. Now it is CloudFormation's lookout how to create these resources, if there are dependencies, if there is a configuration drift, if something fails, how do I retry? Everything is taken care by these services. You don't have to worry about that. The service will take care of it. This is great because now easy to automate. There's a lot of reproduction. You can use the same template to create your test environment. You can create the same template using the prod environment. This is a sample YAML file where I've defined, let's say, a VPC. VPC is a isolated network in the AWS cloud. Okay, isolated network for yourself in the AWS cloud. So you can create something called as a VPC and provides its properties that, hey, I want that VPC to have 192.168.10.0/16 as its IP range. This is my private network. Create this in AWS cloud. So you can create this by providing a proper YAML based or a JSON based syntax. Awesome. But then there were some issues with it. There were no abstractions. You had to provide lots of details. For example, you see this code for VPC and subnet. You're providing a lot of details that are mandatory to create that resource, right? So you have to mention everything in detail. So this sometimes just to create a base network, you will write hundreds and thousands of lines of JSON and YAML files. And don't get me started on missing that single space or missing that certain bracket in JSON or something like that. There are so many times that these issues do happen, and it's not easy to navigate through lots of lines of code, right? So there are some helpers that we created. They were called as document object models. And the idea was to write code in a language that is familiar to me. So if you're a developer and you already have a favorite language, most of people would go for Python or JavaScript or Java or Ruby or whatever. Some of us will have some of the favorite languages that we work with day in, day out, right? And this, I'm talking to the people here who are identifying themselves as developers or DevOps. You have your own favorite languages. What if I told you you could create infrastructure that is more of an ops work? But if you can create infrastructure in your favorite languages, you don't have to worry about, hey, JSON, I don't have to worry about YAML based. I will write code in my favorite language. Now, the DOMs will then convert it into whatever format it has to for finally creating resources in the cloud. You don't have to worry about that. But here what used to happen is DOMs would just create a template, would create that JSON or YAML, which you can then work with CloudFormation and you can work with that. So this was good because now I can write in a familiar language. I can write real code. I can add loops and if statements, and I can create more stuff. Awesome. But still no abstraction. You still had to provide a lot of information. So for example, this VPC, and I'll show you an architecture of what I'm saying about VPC, but the entire base network that you would need for your test and production environments would be of 218 lines. Still a lot of lines, right? I mean, if you are a Python developer and I tell you to go and write your code in C# on which it is built on, you would get frustrated because older days, when you have to print something, you have to write like 100 lines of code, right? Or 10 lines of code to just print something to the console. Now you do that with one line of code, that is print F, just print it, right? See, that's how evolution became in our development environments. Similarly, in these environments also, we have to add in more and more abstractions. So the end user who's working with these tools doesn't have to write 10 lines of code just to print to a console. They can just write one line and everything else is taken care internally. And that is what basic understanding of abstraction is. And you would see a lot of things in technology are just abstractions of something that has been built before. So Cloud Development Kit is also something similar to that. It is just adding abstractions so that you can write code very easily. In Cloud Development Kit, it marries all the good things that we saw previously. Okay, so you still write code in your favorite language and you say, hey, CDK, I've written this code. Just go ahead and take care of it and deploy and create these resources for me in AWS. That's as simple as that. So we picked something from all of these previous works and built CDK. So in CDK, now what happens is you write in familiar language. Yes, you create many AWS resources in one or many constructs. We'll talk about what is construct and what do you do with it, how do construct works. And you would then create it via CDK. So for example, that VPC, you remember 218 lines of code. Now that is just cut it down to one single line of code. 218 lines of code, now you've converted into one single line of code. And that's what the abstraction level is. You don't have to write 218 lines of code, you just write one line of code and we will create the entire VPC structure in the AWS platform. So just to recap, why CDK? Because we have to keep abstracting, we have to make it easy for everyone to come on board and start working with the cloud environments. So AWS CDK. Okay, so let's talk a little bit about that. It came in developer preview sometime August 2018. 2019, we went GA with few languages. Just last year, we've also launched the public roadmap. So if you go and find out CDK, you'll find the public roadmap. All the links will be available towards the end of the talk. So you can just take screenshots of those. Then there is a CDKX and the Terraform one, which we launched in alpha stage. And if you want to know more, what's the roadmap, what's happening, what is coming new, so go and check out the public roadmap. There's lots of changing almost every other day or every month. So let's talk CDK. You have to remember three different components or three main components for CDK. There's a core framework. There is something called as a construct library. and there is a CLI. Okay, core framework, construct library, and a CLI. So let's look at each individually. So when you look at construct tree, you first create something called as a CDK application. You can run the command CDK in it. It will create a CDK application. When you create that app, you also say what language do you want to create this app in? Do you want to create it in TypeScript, in JavaScript, in what language? Okay. Once you create that application, you define something called as stacks. Now in stacks, you define one stack or define multiple stacks. And if you work with CloudFormation or Terraform or these things, that is one CloudFormation template is exactly what a stack is going to be in this case. Just say stacks. Then you have constructs. So a construct could be one AWS service. Now we have a service, a serverless compute service called as AWS Lambda, which you give a code and it will just take your code and it will automatically scale out or scale in, and it will execute that code for you. So you could have Lambda as one construct, or you could add Lambda and API gateway and some kind of storage and something like that with it and call it one construct. Okay, so it could be one resource, it could be multiple resources. Once you define all of this, you run a command called as CDK synth. So synth is nothing but synthesize. So CDK will now, whatever you've defined in your favorite language, will now make sense of that, convert it into a CloudFormation template. Okay, so once it's converted into a CloudFormation template, you run CDK deploy. Once you deploy, say CDK deploy, CDK will automatically take this CloudFormation template, go and tell CloudFormation, hey, this is the template, just deploy this. And it will go ahead and deploy and create all those resources for you. Don't worry if you missed out anything, we will revise these again. So what you do here, let me just take a pen quickly. So let's take a pen. So first you define a CDK application. This is your source code. You tell CDK CLI, hey, I want to synthesize. This is just for you to see, how is this template? How is it created? And we'll also do that. But if you don't want to just check out and you're confirmed that, hey, this is what I want, you just go ahead and tell CDK, just deploy this code, and it will go ahead and deploy this code into AWS environment. Then there is construct library. I will show you the library, but library is mainly what are these different constructs? How do I use them in my language? Are they stable or not? Or are these experimental? And what are the methods and so on and so forth? So I'll show you that. One second. I'll just show you that in the construct library. So this is more like an API reference. If you are a developer, you'll understand that API reference, right? So if I want to create something like an instance, I can just define this. Then you have a CLI workflow. Now let's talk a little bit about CLI workflow. So first is you do CDK bootstrap. What is bootstrap is you create that environment so that it works with the CDK toolkit. Okay, so it's just run this command and it will create whatever it needs for CDK to work with and that region. So remember, if you work with AWS, AWS has different accounts. You can work in different accounts and you can have multiple regions in a single account, right? So you can use different AWS regions like Mumbai region, or you could use a region in Hong Kong or in Singapore or anywhere, right? So you could use multiple regions. So use that in every region that you're going to run. Then you do CDK init. So what do you do in CDK init? CDK init, you say, hey, I want to create an app, or do I just want to create a library so I can share it with other people in my organization, or I can share it with people outside my organization, or you create just a sample app you want to work with. And you mention which language that you want to work with. Then you go ahead and add the constructs. You remember I talked about the Lambda construct or API gateway or storage construct. For example, EC2, Elastic Compute Cloud, is a virtual machine that you can define on the AWS platform. Okay, so remember EC2 virtual machine, as simple as that. So you can then run this at terminal. You can then import this into your code. So you're getting the node, and this is TypeScript. I was playing with TypeScript when I created these demos. So you will find a lot of TypeScript code, but I will show you where you can find any other language code as well. Then you compile your code. I just run npm run watch in the background, and it just keeps compiling whenever there's changes made. You can also run unit test with Jest. So you can run unit tests because now your infrastructure is code. You can run unit tests on this. Then you can do synthesize to create that CloudFormation, deploy. It will not only create the CloudFormation template, but deploy it, destroy if you want to destroy. And diff, if you want to see whatever is in local and whatever is in the cloud, do I want to make comparison, want to see if it is different, you can do that. So let's go and check out the CDK demo. All examples that I've mentioned are available on my GitHub page, so you can go ahead and check that out. So first thing first, let me show you what I'm doing. Okay, this thing is annoying. So let's move this. Okay, so I'm using something called as AWS Cloud9, which is an AWS ID in the AWS environment. So this helps me because then I can just delete an entire environment and create new for any kind of demo. So what I've done in this case is I've just created, sorry, I'll just show you. I've installed CDK. There are a few prerequisites that you can find in the documentation that you should have depending on the language that you're working with. I've already installed CDK. I've gotten all the things that I need. I've configured my AWS credentials and all. Everything is in the documentation, so I'm not going to repeat it here. But what I've done is I've created a blank file. Okay, so if I can zoom in, I don't know if you can see it on Zoom, but this is a blank folder. Let me show you a list. So there's nothing in that folder. Now, if I want to initialize something, so what I will do is CDK init app is equal to TypeScript. Okay, that's all I mentioned. And once I do that, okay, I did something wrong. Sorry, language is equal to TypeScript. See, this is what happens when I type. It's better I copy paste because at times I miss out certain items. Sorry for that. So you say CDK init app, and then you say language is equal to TypeScript. If you do get confused with this, just say CDK init and you should be okay with it. Let it create this app. So it is actually creating a lot of things. As of now, the folder is empty. So it will take few seconds for it to create this. Meanwhile, what I'm going to do is I am going to run. Okay, so it's all done. So am I just going to run npm run watch in that folder so that if anything changes in the TypeScript file, it will automatically convert it into JavaScript files. So all done. So let's go and check out what's in this folder. Wow. Okay. There are a lot of things that it created in this folder. Let me try and zoom in. Okay. So sorry for that. So you can see there is a bin folder, there's a lib folder, there is a test folder, and node modules will have all the node modules that will start importing. It will have that. These are just other configuration files. If you want to change anything, you can do that. What we're going to do is we'll check the bin folder. So in the bin folder, always remember if you're working with TypeScript, just pick up the one that has .ts, not .tts, not .gs, but .ts. In Python and all, it won't be happening that. It's just that we have used JSII to convert these from different languages into CDK. So that's why it's doing that. We'll open this. And right now there is only one in the lib. Okay, let me zoom out. I have zoomed out of this. Let me show you the code first. So this is our main entry point. This is the main entry point, which is in the bin. That is the main entry point. So we have defined a CDK app. We imported the CDK core libraries. We have defined a CDK app. And we will now create a new code. Okay, so this is for the new thing. If this is a new thing, I will not go through that deeply because if you are new to AWS, you'll get a little confused. But if you are someone who has worked with AWS, you want to configure which account and which AWS region you want to work with, you can just uncomment this line and you can add in your details. As of now, it's just creating a new class, a new object of this class or this stack that we have defined is live CDK demo stack. So this is the simple live CDK demo stack. There is nothing. There is just a class that is defined. Okay. And what does it extend? It extends CDK's own stack class that we have defined. It has different constructs inside it. And this is where your code goes. So well, let's do one thing. Let's import something like EC2. So I'm going to create something like VPC, right? So I'm just going to say import all from EC2 from AWS CDK EC2 code. Now it won't find anything like that because the node modules by default should not have that. So what we're going to do is once I define this in my code, I will now go ahead and clear this and say npm please install this particular library or module from your AWS CDK code. Okay. Once I do that, let it finish its work. It'll take a minute for it to do that. Meanwhile, what we are going to do is in this particular example, remember I talked about VPC. So I will define something called as, okay, so it has already created that. I will define something called as VPC. This is the code we saw in the slide as well. So we are defining this .vpc, where we are saying this first one is obviously the scope. What is the scope? It's this particular class. What is the name of it, and what are the different parameters that you want to add in, right? So now it is saying, oh, you're not defined VPC. So I think I missed out adding VPC as a, okay, let's do this. Okay, so let's do this. I'm going to add new constant. So I added a new constant. I'm sorry, I'm still new to working with TypeScript. So I will do a little bit of cheating, but I do want to add it. Let me do a little bit of cheat here. Okay, not here, not here. I'm still a little new to TypeScript, so I'm working on that. Okay, public read only. Public read only. So that's what I want to mention. And I will mention it here. Okay, so what I'm doing is I've defined VPC, and you don't have to worry about it. If you love Python, you do it in Python. I'm still new to TypeScript, and this is for me to learn. So I've defined VPC here, and I've defined VPC, and I've created a VPC resource in this section. Okay, once I do that, now let me show you this magic. Okay, we have bin, we have lib, and we have no other folder here. So let's do this CDK synth. Okay, you do CDK synth and give it a minute. You will automatically see there is a CDK out folder that has been created in this section. So once you see CDK folder that has been created, it has automatically created this JSON file for me. Let's close this for now. Let's close this and let's go to file, fold folding, and fold all. So what is in the JSON file? It has defined two things. One is conditions, one is resources. In resources, it has created one VPC, that is virtual private cloud. It has created a public subnet. So you can see till here, it had created private subnet. It has created public subnet till here. Now it's very difficult to see here, right? It's not easy to understand what is happening. So let me show you what we did. We created an application, a CDK application. Remember, then we created CDK CLI. We used CDK CLI to initialize this application. We made some changes, just a couple of changes in there. We then used synthesize to create a cloud formation template, right? So this cloud formation template that it automatically generated. So what is this cloud formation template? It's actually a lot of lines of code that this particular code executed. So it created this huge template in there, right? What is that code actually created? Let me show you in an architecture format because it's easier to read an architecture rather than going through that JSON. So it created in AWS cloud, it created VPC, virtual private cloud, which is an isolated network for yourself. Then it created two public subnets. Public subnets are something where if you put a virtual machine in these public subnets, they will have access to internet, as simple as that. Then it creates private subnet, where if you put any virtual machines in this subnet, it will not have access to internet. Okay, so two public subnets, two private subnets. Public subnet, so you could put your web servers and stuff that can be accessed from outside. Private subnet is for something like databases, which don't need access from the outside world. So it creates these two. It creates something called as NAT gateways for the private subnet, adds an elastic IP, creates route tables, and it creates a lot of these items inside that just one particular command. So how does it do that? It actually has a lot of defaults that it defines internally. And it's a big topic, but if you want to know more, then it creates a lot of items inside that VPC. And there are a lot of different defaults that it takes into consideration. These are a lot of stability. Let's see. Okay, so a lot of defaults are considered in this particular code. So if you can see, there are a lot of defaults. I have not given it, let's say, a IP address, right? So I'm not given it. Let's go to properties. I have not given this. Did you see this anywhere in the code? No. this was considered automatically by the code itself. So you would say, Rohini, but instead of having just two here and two public subnets and two private subnets, I want to have maybe three items, like two public subnets and 4 private subnets. How do I create that? So if you want to make changes to the defaults, you just have to expand the properties for that particular VPC. So you could go ahead and say, hey, I'm going to add this here. I'm going to say, okay, let's close this for now. For this particular VPC, everything is by default, but I just want to change the subnet configuration that I have. And I want to have, and this subnet configuration means it will create one of each of these type in all the AZs that you have configured. By default, this one is picking up 2 AZs, so 2 AZs. So this is 3 into 2, 6 subnets. Okay, so I've said I want a public ELB, I want a private ELB, private AP, and private database. There are 3 types of subnets in both the availability zones. So the moment I say CDK synth, let's do CDK synth, and it should go ahead and change the same file that we had defined. Okay, so let's go here, let's close it and reopen it. Don't save. So let's close it and reopen it. So it should have, and hold folding, hold all. So now, keeping my fingers crossed. Okay, so it didn't update that. Why didn't you update it? Oh, I didn't save my code. That was bad. That was me. Sorry. See, this was what happens when you do live coding. Okay, let's hopefully this has changed the file and reload. Okay. So it will ask me, it has changed, do you want to reload? So I did say yes. So let's again fold this. And now you should hopefully see, yes, you should see public ELB subnets separately defined. You could see private application subnets separately defined. So let's go back to our architecture and see what happened. So when I modified that code to this, it had the previous things, right? Previously, we had 4 subnets. It added more subnets, that is 2 more subnets with all the routing information that you require. It divided that 10.0.0./16 into all these different subnets, and it also named them according to what names I provided. So there are 2 public ELBs, 2 private, and 2 private databases. Awesome. So it automatically does that. Now, if I want to deploy this, all I have to do is CDK. Sorry, where am I typing? Let's increase this, and let's say, okay, let's clear this, may not be visible. CDK deploy. The moment I say CDK deploy in this folder, it will pick up that, okay, I have only 1 stack. If you have multiple stacks, it will ask you, do you want to deploy in this particular stack or not? I'm just doing a quick time check. Okay, I do have time. And this is what it looks like when it's deploying this particular information that I've given. Now it takes a lot of time because it creates a lot of resources. It will take 5 to 10 minutes to create it. So we're just going to park that because we don't want to see that. As a good chef, what I have done is I have already created a lot of things for you. And that is where my code is in the GitHub. So in my code in the GitHub, what I have done is I've defined 3 microservices. The first microservice is called as Apple. So I define an AWS EC2 instance. So it's just a virtual machine for Linux. Okay. So latest Amazon Linux virtual machine I've defined, and it creates that. I've also created a sample. So you can go ahead and check that out sample. This sample actually goes ahead and creates a Kubernetes cluster in AWS. Okay, so it creates an EKS is Elastic Kubernetes Service, managed service, but it creates a Kubernetes cluster in the AWS platform. And before that, I've defined something called as network stack, which defines the network that we just saw. So you have a base network and it creates all these resources inside that. So I've defined that. I've defined the dependencies as well, that you first need to have a base before you create all these different resources. If you are a CloudFormation enthusiast, you could go ahead and see in the CloudFormation console. This is the one we created right now. And these are the ones that I've already deployed previously. Okay. Now, if I want to create different networks, remember I said I wanted to create a test network and a production network. So in the initializing or the main app, you can now define that. So for example, let me show you a simple example. This is my development network. Okay, I'm just calling it dev network. I'm using the same code to create a dev network. If I wanted to create not a dev network, or I wanted to create something like a prod, I would just have to create this again and call it as prod. So for example, let's say the microservice which creates an EC2 instance, I now want to create it for my second developer. I just need to name it second dev, and it will have the same configuration that the first person had, because both are generally coming from the same template. It's just that they are different environments or different virtual machines that are created in the AWS platform. So if I save this and go back, it will obviously show me that. So let's go and show you something quickly. CDK demo. Okay. So I'm just going to say, let me see if you can see this. I'm just going to say CDK ls, and it will show me what are the different CDK stacks that I have defined for this particular template. So now you would see, hey, I have dev1 and dev2. So let me go ahead and, sorry, let me create something quickly. I'm just considering that, sorry, this keeps happening with me. I have to go inside that folder because otherwise it will not find those helpers. Now I have saved this file. Let's go ahead and save this file and again do CDK ls. Give it a second, we'll come back. It should now have dev.2. See, it now has dev.2. Now, if I want to have dev.2 and I say CDK deploy this particular stack, okay? The moment I say CDK deploy this particular stack, it will go first to check, is my base network ready? Is this parent that I've defined here, is this parent deployed or not? So let's scroll up a little bit. See, it will check including dependency stats. Is base dev network there? Yes, it is there, and no changes are required for deploying this stack. And also takes outputs from there. And it will then ask me, hey, you're trying to do these security related changes, these identity related changes. These are all security changes. Are you sure you want to deploy this particular thing? I can say, yes, I want to. And it will now create a CloudFormation change set. If you know AWS, you would understand this, but it will ultimately go ahead and create this in CloudFormation. So it's already saying create in progress. So let's go to CloudFormation. Let's do a refresh. It's already started creating progress. This is the previous one. It's already done. So VPC has been created. So that's a quick demo of CDK. I don't have time to go deeper into constructs, but just to tell you, there are 3 types of constructs. One is low level. One is where you can define each and every component of that VPC environment. I can define VPC, then the subnet and the subnet and the last. You can do that if you want. Don't suggest doing it, but you can do it, define those separately, and you will get the same type of CloudFormation template. Or you could do something like intent-based, which I created, which was create me an EC2 VPC with all the defaults that you have. So it's the same code with all the defaults, and we will create that entire CloudFormation template. Or there is a third one. So, sorry. So if you have worked with AWS, you would understand common architecture patterns. So for example, there would be ECS, which is one of our container orchestrator services. And if you're creating an containers application on AWS, and you have a standard architectures for that, right? So you could write few lines of code, like 3-4 lines of code, and it will create a lot more infrastructure for you. So for example, this particular 4 lines of code creates a lot of things in the backend. It creates container images, it will create orchestration, it will give you CPU, it will give you networking, it will give you load balancer, a lot of things. I don't have to worry about. If I'm not an ops person, I don't want to be worried about configuring a lot of these things. I can just use my code to generate these configurations and then start running with it. So a lot of solution constructs are available, a lot of common architecture patterns that you would have on AWS. So if you're new to AWS and you just want to get started with something as simple as deploying a load balanced container application, you could just pick one of the load balanced container application constructs and get started with. And how it works is, there are some that AWS has created, but there are a lot that a lot of customers have created, because a lot of customers who use AWS will have these things that they want to work with ready-made. Like, for example, if you have different microservices, you would have a set of understanding that how my microservices are going to be built. And if someone else is also building a microservice on the same kind of architecture, I can just ready-madely give them this construct. They can start using that construct and get go. They don't have to sit and write everything again and again. That's the idea behind writing these constructs. A lot of times you will see stable and experimental. Stable is good to use in production. Experimental, don't use in production. Just test with them, play with them. Don't use in production. Finally, CDK pipelines. If you want this code that you've written can now go into your own CI/CD. Like if you're using Jenkins, you're using GitHub, you can continue using same CI/CD pipelines for this code. Or there is something CDK pipelines which is still in developer preview, but that is something that AWS has also launched. So people who are using CDK and want AWS to create the pipelines for them easily, they can start using that. To summarize, what are we trying to do is we are giving you high-level abstractions for your infrastructure, so you can reuse the same code. You can share that code within your org, outside your org. You can use someone else's code, and you're dealing with code. You're not dealing, and this code I showed you in Cloud9, you can use Visual Studio. It even has a fancy little plugin as well for Visual Studio. So you could use those. You can write object-oriented techniques for creating your code. Now I have some time, so let me just quickly talk about CDK. CDK for Kubernetes, not AWS specific. Anyone can use. If you're using Kubernetes on your local environment, you can use CDK for Kubernetes. It is open source, 3 different languages. Roadmap is still on GitHub. Same like CDK, it will first create, you will use the command changes from CDK to CDK8S. So you use CDK8S in it. Sorry, that's a tongue twister for me. And then you define charts instead of stacks. And these are, if you work with him, charts. Then you have constructs, and your constructs here would be the Kubernetes services or pods or deployments of replica sets, or you can make one construct out of these. Then you say CDK synth, and it will create the Kubernetes manifest file. CDK doesn't directly push to Kubernetes. You have to use kubectl, which is Kubernetes thing, to apply these manifest files to Kubernetes. Okay, so let me show you one small demo of what we are going to do with CDK8s. So this is my CDK8s. I've already defined one application. So let me just see if I can zoom in. Okay, let's do it. So this is CDK8s app. There is just one thing you have to know is this main.ts, which I've already opened, and this distribution file, which already has this created. One second. Let me zoom out. Okay. So in main.ts, similar to that, this is the main entry point for CDK. I have defined one label. If you're into Kubernetes, you would pick that. But I've defined a label for the app. I've defined a Kubernetes service. Okay. So I've created a service for Kubernetes. I'm saying the service is a load balancer type service on port 80, and it has that particular app label that I have mentioned. And I'm also going to deploy this. How many replicas do I need? I need one replica. Do I need anything else? Okay, I need container image name. I need name for it. I need the port numbers. And if there is anything else I need to mention, I should also be mentioning that. So you can then make changes here as per your code. This could be part of a bigger code. You could get variables from somewhere else. You can modify, blah, blah, blah. Once you do that, you just run something. You run CDK8S synth. Same command, CDK8 synth. And what it will do is it will create this dist and folder. So it will show you that this has been updated. This has been updated. So you can see that here. Okay, this has not zoomed out. Okay, so now if I go here, and if you are into Kubernetes, you can see that this is a Kubernetes manifest file. It's a YAML file that Kubernetes needs, right? So you have created this file. So let me just quickly see if I can show you this. Do I have time? Okay, so I'll show you kubectl. Hopefully this is configured with the yes. So this is configured with the Kubernetes environment I created in that CDK demo. So in CDK demo, I've deployed a Kubernetes environment. So it's showing that yes, there is one service that was deployed as part of that environment. What I will do is now I will say, I will say kubectl. Okay, apply. Sorry, -f and dist. It's the file name AWS CDK. So I'm just saying kubectl. This is your file that has been generated by CDK. Just apply that onto my environment, and it should automatically go ahead and create this service for my kubectl environment. Awesome. So it is now saying that it has deployed this. So let's go and check it out quickly. This is an AWS ELB. Didn't copy. Sorry. Okay. Should be able to. Let's give it a minute. We'll come back to this because it has to go ahead and create those services and all that. So we'll give it a minute to come back. So what did we do here? We created a Saintgits application. We used Saintgits CLIs to synthesize a Kubernetes manifest file, and we use kubectl to create that resource on the Kubernetes environment. It could be in AWS, it could be anywhere else. You just have to configure that and you can work. So we wrote a code, we read Saintgits in, and it created that file. Let's see, let's refresh and see if it is up and running. Okay, it's going to take a little while. Should be the right one. Let's see. HTTP. Okay, it's going to take a little while. So Kubernetes or Saintgits work with any cluster outside of AWS, in AWS, anywhere you want, start using it. Similar for Terraform. Terraform also you can use that for anywhere else as well. How do you learn and contribute? First thing you do is you can go ahead and check out. This is available on the website. I don't need to mention that. You can start taking some screenshots if you're interested to learn and contribute to CDK. How do you start with? So this is the first thing you can go and check out how you can contribute to this. Next steps is that you can engage with AWS. There is a GitHub location for that. There is GitHub location also. There is a CDK workshop. If you are interested in CDK and you want to go step by step, I want to see Rohini in different languages. Okay, let's just refresh this if it is up and running. CDK workshop, just go and search for CDK workshop. And the first thing that you will see is the CDK workshop. You can have Python, .NET, Java, TypeScript examples or workshop here. I also promised you I will show you where you can find it, but I will just say, let's not go here. That's difficult to see there. CDK examples, GitHub. Just search for that and you will find an entire folder structure for all the different examples that you want, for Go, for Java, for Python, for TypeScript. If you're into Python, you can also find specific use cases. You can pick up these constructs and start building. A lot of different community resources as well. There are a lot of communities that come together and build CDK. You can find awesome stuff there. There was a CDK day itself. It's become a huge thing amongst people who are interested in developing code for infrastructure. So CDK day was created with 2 tracks. You can go and watch all the sessions from CDK day here. And if you're interested to learn about AWS, if you're interested to learn about cloud computing, there are 2 things you can do. One is you can join a user group in your locality, in your city, or the India user group. And you can join something called as AWS Reskill, which is a community-driven platform that we have on AWS. You can find a lot of challenges there. You can find a lot of sessions, quizzes. You can earn a lot of items. You can earn rewards, and you can build a network. You can find a lot of people who are interested. A lot of students are interested in AWS, so do check out and do reach out to a lot of them. And that's me. So please go build. You can reach out to me via Twitter, via LinkedIn. You can also check out my GitHub location, and I'll look at some questions for me if there are any. Please do write the questions in the Zoom chat if you have any questions. Jacob, are you there?
Yeah, can you hear me?
Yes, I can.
Yeah, so I think we can take some questions from the audience. So yeah, we've got a question. How to start out for building a career in cloud? Any courses or resources that you'd recommend?
Good question. I keep getting this question all the time. So what I will say is, okay, you have to understand one thing. Cloud is not, so use cloud as a complementary for whatever you want to do. What I mean is, if you are a developer, use cloud to build projects. For example, you're a Python developer and you want to create, let's say, some kind of backend microservices application. use cloud as a complement to that and build applications that can be hosted on the cloud. For example, AWS cloud. If you are someone into machine learning, you are someone who is writing a lot of code, use cloud to deploy your machine learning models, or use cloud to train your machine learning models or code in the cloud. You should have something that you already love to do. You could be into development, it could be in machine learning, it could be in databases or analytics or IoT. Find what you want to do and then complement cloud in it. Don't just go learning cloud, because then it's a very vast ocean. You will get lost in that. Okay, so the first thing is find what you do. Are you into operations? Are you into containers, into Kubernetes, whatever it is? Find that knowledge that we already know, and then see, acha, how can I implement this in the AWS cloud, or how can I implement this on cloud? This way you will learn much faster than opening up the AWS documentation or console and get lost in such a wide ocean and a lot of things that we provide, right? So pick up what you know already and then see how you're going to do that in the AWS cloud. That's a very easiest and fastest way to learn. Second is know your core fundamentals. I talked a lot about VPC and EC2 and RDS. Know your fundamentals. There are a lot of things you could do. If you could be in serverless, and you can go ahead and build serverless. But knowing cloud fundamentals is very important. Knowing, acha, if this is about AWS, then AWS, acha, where are the data centers? What do they call it? What is the terminology for that? We called it regions and availability zones. Acha, what are these regions and availability zones? How do I create virtual machines? A very basic thing. How do I create virtual machines in the AWS cloud? What are the different kinds of storage do they provide? What are the different kinds of databases they provide? If you get a little bit, I'm not saying deep dive understanding, but you should have a little 100, 200 level of understanding. If anyone asks you, acha, I want to host this on AWS, can I do it? You should be able to say, okay, you can do this. You can use these two services and you should be okay. Okay. So first thing is find your niche, build that team. So know what you want to do. And then you also learn about cloud and different vendors, or you know about AWS and how do you do things in AWS, but find that niche. And the second is, whenever you start with a new cloud provider, try to learn from the basics. The lot of times what happens, and a lot of you are students, right? A lot of times you would know a lot of things more than people who are already in the market, because you should be doing the basic groundwork rather than just learning something from top. That is my understanding, that I will always ask people to start from ground up, learn something basic, and then you add in those abstractions and those easy ways of doing things. But for example, if you're working with Python and you don't even know that, you don't really have variables in Python, but you go and, those are the address points in Python, something like that. If you don't know the basics of how Python works, if you're going to go and become machine learning expert, but you don't know how basics of Python, and you're creating code that is going to fail in future, then that is not a good way, right? So you would know basics of Python. Similarly, know basics of cloud. I hope that answers your question.
Yeah, do we have
and
more,
course wise, third thing I wanted to add was, course wise is, some people, there are a lot of courses on Udemy, on A Cloud Guru, on a lot of third-party ones. Even AWS has some courses as well. You could access those. You could go to Reskill platform. Some people, and most of the times this is students, we learn better under pressure, right? But then there is an exam tomorrow, we'll start studying 2 days before or a night before that. So book yourself a certification exam, and I hope that motivates you to study for that certification exam, and study for an associate level, which is, or a study for an associate level, learn for a practitioner. I would suggest not giving practitioner exam, because you will be spending money for it, and I just want to save some of your money. So study and give an associate exam. I think that is the best motivation for anyone to start learning. Sorry, I'm done. Thanks, Jacob.
Yeah, do we have any more questions from the audience? You can either unmute yourself or you can post the questions through the chat window.
And if you have more questions, if you want to play with this, just go ahead and play with it. If you have more questions, feel free to reach out on Twitter, on LinkedIn. Sometimes I do have delays in getting back, but do reach out. There are a lot of amazing people here who want to learn. And I do want to leave you with this. Do join Reskill if you are a student and want to learn. It's a very good way of building your network with AWS Cloud. A lot of, we have like 31, that's the last number I heard, but 31,000 people as part of this community who are being taking care of this, and you can earn a lot of things here. So if you want to learn more, just go ahead and do that. But thank you. If there are no more questions, then thank you so much.
Yeah, thank you, Rohini. It was a pleasure to have you.
Thank you. Have a good day. Thanks, everyone. Bye-bye.
Hello, Ibrahim. Can you hear me? Your microphone is muted.
Yes, hi, good morning.
Yeah, good morning. I think your video is not on. Yeah, it's on. It's on.
Yes. Are you able to see my screen?
Yeah, we can see your screen.
All right, awesome. So good morning, everyone. Good afternoon.
Yeah, Ibrahim, we'll just have a short intro with this introduce you to the audience.
I'm sorry, Jacob, you're cutting off.
Can you hear me?
Yes, I hear you.
Yeah. So let me just introduce you to the audience. Ibrahim Hadad is the Executive Director of the LF AI and Data Foundation. He works with the largest technology companies and open source communities to facilitate a vendor-neutral environment for supporting and sustaining development and innovation in open source AI and data projects. So prior to joining LF AI and Data, Ibrahim had served as the Vice President of R&D and Head of the Open Source Division at Samsung Research. He's got an immense experience in AI and machine learning. Throughout his career, Hadad has also served, has held several technology and portfolio management roles, especially at Ericsson Research, Open Source Development Labs, Motorola, Palm, and Linux Foundation, and PhD. It is our pleasure to introduce to you Ibrahim Hadad, the Executive Director of LFAI and Data Foundation. Over to you, Ibrahim.
Thank you very much. So as at the beginning, I would like to thank you for inviting me to this event and having me and allowing
Ibrahim,
me to.
sorry to interrupt you. I think your video is not on.
The video is not on. Just 1 second. The video is working from my end.
It's okay, Ibrahim. I think I will. Thank you.
So the video is allowed on my Zoom side, so I don't think.
Here we can't see you, but it's okay. Ibrahim can start. Thank you.
Just 1
We
second.
can see your slides. We can see your slides.
Okay.
Okay, thank you.
So good morning, everyone. Thank you for having me at this event. My name is Ibrahim, and I am the Executive Director of LFAI and Data. We are a foundation under the Linux Foundation, and we focus on AI and data. My presentation today will kind of touch on a number of topics, and the first thing I always like to start my presentation with is kind of an ecosystem overview. Basically, what is happening in open source AI and data, how many the projects, the communities, and so on. And really, open source has been really exciting development from an AI perspective, as similar to other technology domain, whether it is networking, cloud native computing, and many other domains. Open source really just lowered the entry to the domain better than anything else that came before it. So basically today, even if you are not an expert or have a lot of knowledge on machine learning or deep learning or any other topics, just with the help of the available resource in open source, you're able to enter that domain. So when we look at the ecosystem, you will see from this slide, there are really a lot of active projects in the space. So this is I will take a minute to explain the graph you see in front of you. This is the open source AI and data landscape. We basically feature top projects in these various subdomains under AI and data. So you will see there's different categories. There's machine learning, deep learning, data models, security and privacy, notebook environments, trusted and responsible AI, and a few others. And within each of these major categories, we have subcategories, and we have the projects distributed where they fit best under these different subcategories. So what you will notice is we have a little over 300 top tier projects. All of these are critical, very active, growing projects that are coming from over 140 organizations. Of course, there are thousands of companies involved in the development of these projects. Even there are some of these projects you see on screen were initiated and created at universities. I think there are at least 10 of them that were started as university projects and became very popular and kind of de facto standards in their own functionality within their categories. What's really interesting when you look at this is there are kind of different remarks. The first one is there are a lot of projects in some of these subcategories leading to fragmentation. So for instance, if you look at machine learning on the top left, if you're looking for a machine learning platform, there are probably a dozen projects that you can pick from. Or if you're looking for, under data, a store and format, a library, there are, a dozen, and so on. So there's a lot of projects that are more or less providing similar functionalities and are competing for audience, developer, and adopters. That's the first remark. Second remark is when we look at all of these projects together, the 309 projects, there are over 40,000 active developers contributing to them. And this is really massive for just around 300 projects. So that's a lot of developer time being put into these projects. And totally, all of them together, they constitute about 450 million lines of code. So this is a lot of code, but what's even more interesting is the fact that every week, there's 1 new million lines of code added to these projects. So there are a lot of actually ongoing activities, and it's a very active and growing ecosystem. And all of these libraries, frameworks, platforms, and everything you saw on the previous slide, they're actually two-way street by the fact how open source work. So they basically make the tools and the libraries available to anyone to use. And then from the other side, companies can benefit from them and contribute to them, which leads to faster acceleration of such applied AI research. So we all know the source and how much time it's in different fast time to market, the ability to innovate, the lowering the barrier to enter the domain, better products, improved quality, et cetera, et cetera. So there are really a lot of tangible and strategic benefits to open source. However, when it comes to AI and data, there are some very specific and unique benefits that only apply to AI and data in this case, and that makes it really stand out for this domain. And these benefits are in relation to the general concept of trusted and responsible AI and the concept of open data and the tools needed to manipulate and enhance these data that we feed into models at a later stage. So when you look a little closer, the specific domains under trusted and responsible AI are focused on fairness. These are methods used to detect and mitigate bias and make sure they are fair in data set and models. The concept of robustness, which are basically methods and tools and libraries used to detect if there has been any tampering with data set and models. The concept of explainability, which are basically methods that allows us to provide detailed explanation on how a model decision has came about. And lineage, which is basically tools or methods or models that allow us to understand the provenance of data set and AI models. And underneath these different concepts, there's open data, which is data available under an open source license. that makes it easy to use the data without any kind of mechanism of control from the organization or the people or the company that made the data available. And of course, when we have open data, we need tools to manipulate this data. And of course, what makes open source really special in this case is the transparency and openness of development that allows us to know exactly what is a fairness library include, how it has been developed, how it makes its decision, its algorithmic decision, and so on. So the transparency and openness is extremely critical when working on AI and data due to the sensitive topics in relation to trust and ethic, and open source offers major benefits in this space. So despite the fact that it's a very growing and very active ecosystem, there are a lot of challenges. So what you see on the screen is kind of an illustration of these different challenges, starting from the bottom up. There are challenges in relation to fragmentation, a lot of projects, lack of integration across projects. Of course, when you have so many projects, it's very hard to integrate with all of them. You have to be very selective on how you spend your time. So you end up integrating with just the base minimum of projects that you know will be used in conjunction with your project. There are governance-related challenges. These challenges are in relation to who runs the project, how decisions are being made, etc. And typically, in most cases, governance basically favors the creator of the project. In some other cases, there is really no governance, and the project backer really dominates the decision-making and the development and the governance of the project. A lot of these projects you saw on the screen were developed internally for a specific product. It was either kind of a feature of a product or a product. And over time, the company behind that specific feature or product realized that the value is actually in the models, in the data, and the apps built around it, and not specifically in the framework or the library or the methods they're building. And then they went and open sourced those. And that's how we end up with multiple projects coming from multiple companies, more or less providing the same functionality. Because a lot of these efforts were done internally in parallel without any type of collaboration. And then companies decided to make them open source. And this is how we ended up with multiple competing projects in the same categories. And when a project grows and becomes successful, it becomes really a challenge on who's going to manage the assets of the project. Who's going to own all the legal administrative tasks, such as compliance, such as trademark management, such as export control filing, who's going to pay for AWS credit to run the test of the project, who's going to build the website. There are a lot of such administration, and it becomes cumbersome when there are multiple companies involved in the project. And all of these challenges together create a ceiling for project adoption. So if you are a company and you want to adopt a project for your product or service, you want to make sure that it integrates well with many other projects that you use. You want to make sure that it has an open and fair governance. So if you invest in the project, you have a path to becoming a maintainer. You have a path to becoming a decision-making in the process. You need to make sure that the assets of the projects are run in a neutral environment and it doesn't favor one company or another. And this is really all the different motivations to set up LFAI and data to work in this. So we are a nonprofit organization. We are a Linux Foundation umbrella project. We are a collaborative effort, and our goal is to accelerate development and innovation in open source AI and data, hence our name, LF for LF Linux Foundation, AI and data. A little bit of history. We were launched almost a year and 3 months ago, 3 years and 3 months ago. In March of 2018, we were just 9-member companies that came together and decided to launch the foundation. And we had only 1 hosted project in the foundation. And over time, we grew today to host 31 or 32 different projects in the foundation. And we have, I think, 50 different member organizations coming from across the globe. In terms of how we're structured, we have very simple structure. What you see on the screen is the kind of different governance structure in LFAI and data. So on the right-hand side, these are the projects that we host and in incubation, and we support with a number of services to help them grow their user base, to help them grow their developer base. In the middle of the screen, you see the technical coordination body. This is the what you call TAC, T-A-C, Technical Advisory Council. This is really the technical body. It includes technical representatives from all member companies in the foundation. And there are a number of subcommittees within that council focusing on different technical aspects of the work being done in the foundation. So we have one focusing on ML workflow and interoperability. We have one focusing on trusted AI, one on BI and AI, and another on ML operations. And on the left-hand side, we have the funding effort, basically the governance of the foundation itself. We have a board for the foundation, and under the board, there are a number of committees focusing on strategy, marketing, and PR, and communication, legal, and budget. And of course, from a hosted project perspective, each of these different projects, they have their own governance structure and they run themselves, and there is really no intervention between the governing board, for example, and the technical project. Technical projects are completely independent in their structure, and they have their own technical governance, and there is really no influence from the governing board into the host project or otherwise. As you see on the screen, we have 3 levels of membership. The premier level of membership consists of companies that are on the board, followed by the general membership. These are companies joining us to support our mission. And for every 10 members at the general level, there is a board seat assigned to them, up to 3 board seats. And the part I would like to get to your attention is actually the associate level of membership. This level of membership is or has the same benefits as the general membership, but it's dedicated for academic institutions and government labs and nonprofit organizations. And it has no cost associated with it. So you can see there are many universities from the US, from China and other parts of the world, and from India that actually joined us and that are active in our foundation. In addition to even other nonprofit organizations working in this domain. So we have, for instance, AI for People from Italy. We have Open UK from the UK. We have the Ethical Machine Learning Institute from the UK as well. There is the Montreal AI Institute from Canada, and so on. So from an academic perspective, this is really an opportunity for you to join the foundation and become a member and be active in our efforts at really a lot of opportunities for opportunities. There's a really good experience. Internship opportunities with the companies that are members in the foundation, collaboration opportunities, publication opportunities, free access to some of our events, and so on. So quite beneficial, especially for academic institutions. As I mentioned, projects. What you see on the screen is the most updated projects. And of course, if you visit the landscape, you will be able to click on each of these projects and get a lot of information and links to learn about them and learn how to get involved in them. The landscape, but we only show on it our projects. So this is to give you an idea of the areas we're focusing in. So we have a lot of projects in the data space, in machine learning, in distributed computing and models, and trusted AI. And our goal is really to have at least one project in each of these subcategories, so that companies who are looking to adopt an open source project for their AI and data, they always have an option in any given category to have an open source project in the foundation with a neutral and open governance for that. I think 6 or 7 different, and pretty much everything we do in the foundation funnels into these different buckets. Develop and grow the ecosystem, enable collaboration across projects, provide unified guidance to the end users, harmonize the space, or basically, in other words, reduce fragmentation, and of course, specific instance of funding, provide funding for these projects that we believe have very solid technical backgrounds and are aiming to become kind of de facto standard in their own categories. And we have a number on the bottom, some other efforts related to ethical AI, to ML ops, and interoperability, and providing a machine learning workflow end-to-end with open source projects hosted in a foundation. Very growing active developer community within our foundation. What you see on the screen are the numbers for 2020. And as you can see there, we've had almost 9,000 contributors to our projects, over 100,000 commits, and some other related statistics. But what's really interesting, 2021 to June 7, these numbers have increased to 2020, and we have anywhere between 5 to 12% increase year over year over these different metrics. So for instance, we were at 8,900 or so contributors to our projects. Now we're at 9,660 contributors. The number of commits has grown, number of issues in our projects. There's
issues from your
you
side.
can get a lot.
We can't see your screen.
I'm sorry?
We can't see your screen. I think you got some network issues from your side. The screen is black. Can you hear me?
Yes, I hear you. I'm sharing again.
Yeah.
Is it working?
Yeah, now we can see. Yeah, thank you.
What happened? And all of these stats are available at our platforms. You're able to log in via the link you see on the screen and access such data. So in connection with our technical work, we have activity focused around marketing promotion projects. As you can see on the screen, we've just for comparison 7 in relation to project announcement, project cross collaboration, cross projects in 2019, and then in 2020 we almost double that number. And actually for 2021, we're actually this is old information. I apologize, I didn't update it, but are actually going even stronger in 2020. And in addition to that, we have our own activities in relation to events. So we in Foundation Open Summit, which happens 3 times a year. We have an AI track, the Kubernetes we have an event, and so on. So we're very active in our projects together with other communities as well to develop that sense of community and grow the projects. So I will skip these couple slides just for the sake of time. And one slide I'd like to note is, who is hosting projects with us? As I mentioned earlier, we have 32 projects hosted in our foundation, and these projects are coming from a number of companies. So we have on the screen the companies hosting their projects with us. So we have companies from the US, from Europe, we have companies from China, from Singapore, from India, and many other parts of the world, and are really large tech companies. And they decided to trust us with their projects because we have the skills and expertise to enable small projects to grow and become really influential and highly adopted in their specific set and category. So why these companies incubate projects with us? We are a neutral organization. We offer a technical, open, and neutral governance for all of our projects. We actually have dedicated staff, people who are dedicated to supporting these projects. We have staff supporting in events, in marketing, in legal, in IT and infrastructure. We provide training and certification support for our projects, so we can create, and we did create classes that we publish on the edX platform. We have the ability and the infrastructure to create certification for the project. We have an events team to support us in terms of events ranging from really small, 50 to 100 people, to events up to thousands of people. We provide a number of services for our developer through our developer operations that include the LFX platform I mentioned earlier, IT infrastructure support for our projects. We provide endorsement and mentorship by the tech community to our projects, marketing, events, support, and data support. And I think I touched on these much more time on this. And all of these are really required to grow that ecosystem and make it even more vibrant and provide a sense of neutrality across these different projects. So a lot of companies join us, and of course, every different company joined for a different reason. But basically, some of the companies join to support our mission and help us fund the services we provide to our projects. Other companies join because they want to demonstrate thought leadership in the space and participate in our various technical, marketing, and networking activities. Some companies join because they want to have influence in and contributions into the projects that we host, and they want to be part of defining these technologies, and so on. So there are really many different reasons and motivations for companies to join us, and of course that includes universities and R&D organizations. So I would like to invite you to join us. You can email us to info@LFAI Data Foundation. This is actually a forward email, and I got a copy of all that notice sent. If you'd like to join us, you can just follow the link on the screen. And if you are managing or maintaining an open source project that fits our scope and mission, I'm definitely open and interested to hear from you and discuss with you the possibility of hosting the project with us. So with that, thank you very much for giving me, and 30 minutes just exactly on time. And I'll pass it back to you, Jacob, for any possible questions.
Thank you, Ibrahim. Do we have questions from the audience? Feel free to unmute yourself and ask the questions, or you can post directly in our chat box. Yeah, Ibrahim, I think we've got a question. Yeah, so how can institutions from India collaborate with LFAI and Data Foundation? And is LFAI Data Foundation providing internships for students?
So we as LFAI and Data, we don't provide internship opportunities. We don't have that feasibility, but the member companies that are members in LFAI and Data, they do have that. So some of these opportunities become available through the project. So if you join, so if a university join us, and this is at no cost, and become involved with our effort, then they will have visibility to the project, and they will have students working on this project, and then that's how opportunities become available. Because, for instance, if you are a company using a project X that is hosted in LFAI and Data, and you see students from universities active in this project, you would give them priority for internship over students who don't have experience working on the project, right? And I think we have at least 2 universities from India that are members, and we also have Tech Mahindra from India, who is on our board. That's the highest level of membership. So we have representation from India in our foundation, and you can go to our website and see what universities are active with us and kind of have an opinion that you build yourself around this.
Yeah, Brian, we've got another question. Yeah,
Hello, Ibrahim.
Yes.
Yeah, we've got another question. What is the future of open source and especially in the robotics industry?
Well, I think in general terms, whether it's robotic or any other kind of domain, the future for open source is very bright. I mean, we've seen it for the past 20 plus years, how open source is kind of entering each of these technology domains and becoming a de facto way of building software. It's very hard to argue against open source. I mean, the power of collaboration and the power of everybody coming together and contributing to build base technology is extremely useful and provides a faster path to innovation than going inside a room with four walls and trying to build it yourself. So whether it's robotic or anything else or any other kind of specific technology, I believe that, and we've seen it in other domains, up to 80% of these different technologies are being built as open source technologies, and companies are building the last mile, the top 20% of that stack as proprietary. There is specific IP for them. So, and I see the same applying to robotics, and it's just a matter of time. And typically it takes a few years. So if you look at the cloud native environment, if you go back 6-7 years ago, there were just a couple of projects, and the Linux Foundation took the lead and established CNCF and hosted Kubernetes. And today, you cannot really create or build a cloud or create a cloud business without relying on at least 80% on open source software. And I expect to see the same thing. And similarly, it is the case of AI today, and similarly the case with robotics.
We've got another question in the chat. How can open source support in ensuring more data to support AI algorithms?
So we actually have a number of initiatives. We created at the Linux Foundation the CDLA license, Community Data License Agreement. This license is, as you know, licensing for data is very different from licensing for software. And we did not believe that the existing licenses, such as the Apache, MIT, BSD, and GPL, and others, are suitable for data. So there was an effort that was launched at the Linux Foundation that led to the creation of a data-specific license. And we've seen a new version of this license come out, I think 2 weeks ago, with announcements from Microsoft and IBM open sourcing data under these licenses. So there is an active effort in that space to make sure that data is licensed under an open license that is specific to data, which which will allow access to this data by anybody who would like to use it and build on it. So this is ongoing. And I see a question on the chat in relation to ethical issues. So there has been, and so ethical AI is a very hot topic. There are even governments involved in setting up their own offices that looks into matters in relation to fairness and ethical and trusted use of AI. And a lot of companies are putting the major efforts in the space. So in LFAI and data, we have 3 technical projects that focus on this topic in terms of fairness, trusted, and explainable AI. These are technical projects, meaning source code being created that will evaluate if a model is being biased or not, and if a model or a data set has been tampered with, and so on. In addition to technical projects, there are efforts in terms of policies and guidelines and kind of general guidance given to end users. We've recently published a white paper that touches on 7 critical principles that I would invite you to go and visit our website to download it. So there are a lot of efforts in the space to make sure that such technologies are being used for good purpose and don't have any side effects, any negative side effects.
Thanks, Ibrahim. Can we take one more question, if you don't mind?
Yeah, of course.
Yeah, so Linux Foundation has been organizing a lot of open source summits, especially throughout the year. So is there any initiative from the LFAI and Data Foundation? Can we expect an open source summit purely on AI or an AI-based summit?
So what we've done was in the first 3 years of our existence as a foundation, we've always had our events co-located as part of the Open Source Summit. So the Open Source Summit is the largest conference we have at the Linux Foundation. And in each of the Open Source Summits and with our larger events such as KubeCon and networking events, we have a 3-day track focused on AI and data. So we've always had very strong presence really. At any of these events, we typically have 18 to 20, 21 talks focused on AI data. And I think for 2022, our goal is to have our own event, meaning it is not a track in a larger event, but it is an independent event. This is what we're aiming for 2022.
Yeah, thanks, Ibrahim. I think we don't have any further questions from the audience. So it was a pleasure to have you. I know that you're joining from Lebanon. Okay. Take care, stay safe. Looking to get in touch with you in the future also. So thank you so much. A big thanks from the entire team of Open Source Summit India 2021.
Yeah, thank you very much for everyone who attended and for yourself, Jacob, and the organizing team. I really appreciate it.
Thank you, Ibrahim. So for the participants, we are winding up the forenoon session here. We'll be having the next session at 1:30 p.m. exactly. So it will be a hands-on session, web development using, web development using Python, Flask, and we will be focusing on the Open Event Day platform. So web development with Python, Flask, and JavaScript, and getting started with Open Event Day platform. So kindly log in by 1:25 p.m. We also have an interesting session on GitHub. So we also request you to install Git and Open SSH as a prerequisite for the session. So it will be taken by Yang Bin Han from Korea. So we have 2 exciting workshop sessions coming in. Thank you. Have a good lunch. See you back at 1:30 p.m. Thank you.
He is a Code Heat winner for the term 2019-2020 and was the team leader for the runner-up team in Smart India Hackathon for the year 2019. I welcome you, sir, for the workshop on web development with Python, Flask, and JavaScript. Over to you, sir.
Okay, thanks, Aaron. Okay, so that was a very detailed introduction of myself. So yeah, I'm Pratik, everyone. And after the workshop, also feel free to reach out to me. I go by the username PratikJ117 almost everywhere. I'll just write that in the chat. Okay, so for this workshop, I basically want it to be two-way. I don't want to just say things, and I want everyone to understand as well. So please, whenever there is any doubt, anything, let it be anything stupid. If you think it might be stupid, there's a good chance it might be not. So just feel free to interrupt me and ask me any questions if you have. With me, I have also called Sundaram. He is also in Fossasia and contribute and interning there right now. So Sundaram, can you give a little intro about yourself?
So hello everyone, this is Sundaram Dubey. So I'm currently Chief of Developer for Fossasia and also incoming SDE at the stadium. And I have recently completed my undergraduation for the HBTI Council.
Okay, great. Sundaram, can you mute yourself? There's some disturbance coming from your side. Sundaram, can you mute yourself?
I have already muted. It was.
Okay. Okay. So yeah. So for the workshop, I actually made a new AWS Linux instance just to show you how you can set up open event. Along whenever we will come across any commands or anything, I'll just tell you the concepts, what things go behind each of the commands that we are writing. So this will also give you a pretty good idea of other open source projects, whichever you are planning to contribute to, web development related, how you can set up a local database, and how a basic Git workflow work. I won't go too much into that because I see you already have another workshop planned for that. So I'll just give a basic idea. I'll clone it. I'll show you how you can ask for issues and make a PR, and how you can start with your open source contribution in any organization, and what are the various things that you need to take a note of. Uh, so I'll start by sharing my screen first of all. Okay, is it visible?
Yes, it is.
Okay, so I'll just increase the size. Okay, so this machine right now has nothing. It's a AWS instance, a simple Linux instance. I only install ZSH in it because I like it over Bash, and it will also help you guys to see what Git branch we are in and everything. Other than that, it's a simple Ubuntu that has just been installed, and it's a very fresh install. And there's nothing else. So I'll just start a new teamwork session for the workshop. Okay. So first of all, let's first make a simple directory and clone every project of Fossasia, like the open event server for now, in it. So first of all, what is git clone? Git clone is basically you are kind of downloading the code and the various branches of the particular project which you want to contribute to. So for example, whenever you will go to github.com/Fossasia/open event server, you will see an option of code and a symbol of download. Whenever you click in it, you can just clone the code through HTTPS, SSH, and now there is also GitHub CLI. Sundaram, please share the links as I speak. First of all, of OpenEnd server. Yeah, that's it. Though what the general workflow I follow is I always fork the repository first and then clone it. That is to set the Git reports properly. Whenever you are trying to contribute in a project, the main issue that is there is you don't actually have the right to push a new branch to that particular project. You can't simply make a new branch and push to the project and make a PR by it. You first of all need to fork the project. So forking basically means it will make a copy of that project in your personal account. So for example, if I clone Open Event Server, this is my URL. So rather than Fossasia here, it's pratikdev117. And it for me, it's always better because it's kind of the convention to name your forked repo as origin, and to name the main repo, that is Fossasia/open event server in our case, to name it as upstream. So I'll just git clone it. Okay, so you see it's been cloned now. And now we'll see what are the various. Okay, so we have it cloned. Now we get into that. We see that we are in development branch here. Okay, and let's see what remotes are set. If you don't get this, don't worry too much about it. It's a simple git clone command. I'm just telling the best practices and whatever thing should be set up in the beginning itself, so that anyone doesn't have any issue when they are following this. Also, feel free to follow this. If currently you are on a Linux machine and are planning to contribute to Fossasia, feel free to follow the installation alongside me. Now, say I have Pratikya 117/open event server, and someone actually pushes a new commit in the development branch itself in Fossasia/open event server, which is the original repository. So I need to keep a track of that repo itself. Whenever someone will push a new branch, my forked repository won't be updated by itself. I will actually manually have to update it every time someone pushes a new branch or a new say commit or anything. So for that, I'll also set a remote for upstream branch, and that would basically be the original GitHub repository of Fossasia. So that would be okay. So now we'll see, we will have upstream and an origin. Okay, so now let's get started with local installation of the server. So first of all, for Eventia, we have an open event server and an open event frontend. The server is basically an API. Can someone tell me what an API is? Okay, even if you don't know, you just feel free to say no. I really appreciate like active participation in this. Yeah, it's application programming interface. So basically, that is how an application can like provides an interface for other application or other users to interact with and get the data from the application. Yeah, for sending a request and get some work done. Exactly. Thanks, Joseph. So basically, the thing is that whenever, say, you want something, you want some data related to a particular from a particular service. So say from Facebook, for example, you need to know what are the various friends of a current user, and say you have the right authorization for it, and you are actually authorized to own that information. So you can directly just see what the particular API call is for that particular information. You can make that API call and you will get that information. That is what an API is. So if, like, say for Eventia as well, we have an API, you can make various front ends, say Android client and iOS client, web client, which we have already, or you can make your own web client and then use that API. Okay. Yeah, so API is the main, you can say, interface where they also handle the logic as well. Front end just displays the logic, it requests the logic, it requests for a particular logic to be done. It can be anything. It can be to create a row in a database, to read a row, to update a row, to delete a row. It can be anything. But the API call and the type of request that has been sent, we all know there are multiple type of requests. There is post request, there are get requests, there are delete requests. So there are requests like these. So you can basically make the request, and the API would read that what particular kind of request that user has made, and then run the corresponding function which is associated with that request. Okay, so let's say that I make a request /v1/users. V1 is basically version. So API also have versions to maintain, because as API are being used by many clients, you can't simply change the logic or any breaking change in a API without like breaking other services. You might break down many services by bringing one small breaking change to your own API. So for that, it's always better to version your API. So that is called API versioning. And these are the principles that are kind of followed by REST APIs. So REST APIs are basically a kind of principle. REST is a kind of principle for making an API. So you follow certain kind of practices when making an API, and your API is a REST API. Okay. So now we have Open Event Server locally on the machine. This is basically the code. This is nothing else. These are the files that are present in the code, nothing else. It's just the code that is in your machine. Sundaram, can you also share the link to the local installation of the Open Event Server so that everyone can have a look at that?
Okay, yes, yeah, answer.
Okay, so first of all, whenever you are going to contribute in a project, there is always a README, and it's the best way to start. README basically is a project is everything what it does, what it has been made for, and how you can contribute in it, and various things. Every organization might follow a certain kind of practice that might be different in their own way. They might follow some other practices for some other things, might follow some other practices for some other things, whatever they think or deem is best for their particular use case, for their particular organization. Okay, so Redmi is the best way to start whenever you are trying to contribute to a project or even know in depth that what are the various things that the project does, or look for the documentation link. README is the place to start. You just go to the README and start it. Yes, Archana. So the thing is that we suggest Linux. Yeah, Sundaram, thanks. Sundaram can answer all this. Yeah. Okay. So first of all, let's start with Open Event Server. Now so there are also public channels that are available. For example, in Fossasia, we use Gitter. Other organizations might use some other channels, and we personally use Gitter. You can just go to the Gitter, introduce yourself if you want to, or directly just say that I want to work on this issue or on this issue, or you can directly also comment on the issue itself. We will cover this in more detail later on, how you can ask for issues and what are the best practices when you are starting to ask for an issue to see which issue would be best for you. Would you be able to solve it or not? These things. Okay, so now you will see that to run the Open Event Server, it is required that you, in the local installation section, which is this one. First of all, it's required that you have Python 3.8, you have Postgres, and you have OpenSSL. And you can see that the documentation simply, first of all, says you can git clone it. Then after git cloning, you can add a remote upstream, which we have already done. And then we will install the system dependencies that are required. So let's come on to Debian or Ubuntu. So we see that there is already a command present. We'll just run this for now. So these are the various dependencies that are required already by the server to run. Okay, thanks, Prajwal. Yeah. So yeah, it's definitely possible, and you can just run it on Windows and Mac OS as well. So the steps are the same. Everything is the same. Commands might change a little bit. Whenever you are like starting the server, you know you will need a database. We use Postgres. Okay, you will need to make the tables. You will need to run the migrations and things like that. So it's like yeah, WSL is the best. If you can use WSL too, everything would be much easier. You can even use the same commands. This is weird. AWS is a very slow internet connection. Okay, anyone has any questions till now? Feel free to speak up if you want to. Okay. We are just looking at the commands in Git that are useful here. Git actually just played the role in this first 10 minutes. It won't be playing any role for now. After this, we will actually be setting up the database, running migrations, installing Python. Okay, and yeah, so next topic would be about the database, what are migrations, which ORM we are using specifically, and which library we are using for the REST API in Flask. And I'll maybe show some making some request in the API itself and things like these. Yeah. So Git is just playing a little role in the beginning itself, and this is all, everything is documented. So even if you don't get it in the first session, like I'm always open everywhere else on social media, you can like feel free to reach out. And other than that, we always have the official documentation, and it is kind of very updated as well. So you can just look into that. So next step that we are going to perform is install Poetry. Now, does anyone know what is a Poetry? Like, sorry, what not is a Poetry? I meant, so Poetry uses virtual environments. So does anyone know what are virtual environments in Python specifically, or anything in general? Okay. Yeah. Okay. Yeah. Thanks, Joseph. Correct. So what happens is, say I have Python version 3.8. Okay, and I have a project. Let that project be A, and I'm running the project A. For that, I install the various dependencies that are required for that project. Say that project required Flask, a particular version of Flask. Let that version be Flask 1. After that, I install another project. Let that be project B. And for project B actually requires the version of Flask that is version 2. So now, whenever I would be working on project A, I will need to downgrade my Flask if I'm switching from project B. And whenever I would be working on project B, I will need to upgrade my Flask each time I'm going to project B. So what virtual environment does is, you can uh, take the example of a room. Say we have a room, which is your operating system, and your dependencies are a guest. So whenever you install the dependency, it is being installed on the whole system itself. So whenever you release a guest, that would spread in the whole room. Okay, and say and take virtual environment as an isolated box. Say you have an isolated box and you put everything that you want in that particular box and just close it. And whenever you want to work in that particular box, you just go into that box and start working. So that is what a virtual environment is. You can create a virtual environment for a specific project in Python. You can start working on it, and then after that, whenever you does not want those dependencies or are not working on that specific project, you can just deactivate the environment, come back from the environment. Yeah, it's like a containers. It's like a container, but not exactly. Like, it does not isolate anything else. You the system-wide dependencies would be the same, everything would be the same, just that particular dependencies of the particular language. For example, in case of Python, we use Python env, and so it only isolates the Python environments in detail. Okay, So for making that environment, we are actually using Poetry. Poetry is just a tool that helps us making that environment. Okay, so we have the command of the Poetry, and you're going to see a error here for sure, and I'll explain you why. So this is the command, and this command is basically nothing. It's given in the README, or you can just go to the official Poetry page and see how you can install Poetry. So these are basically the dependencies that are required by the project. Okay, we see Python not found. Okay, right? Like it's a new system. We haven't installed Python yet. How would it be there? Okay, so let's install Python first of all. Now, there are multiple ways to install Python. Sometimes it is directly available by apt, which is the package manager for Ubuntu. Okay, so let's see if it is in our case. Okay, it's not. The particular version of Python that we want, it's not available here. So for that, what we do is, we will first need to install Python separately. We will maybe need to build it or use some other tool for installing Python. In our case, we most of the times use PyEnv for that. It's actually a very handy tool. You can simply install PyEnv and then simply write commands like PyEnv install 3.8, and it will install the particular Python version that you want. So let's go to the PyEnv documentation and see how you can install PyEnv. Okay, so this is the command I basically copied from the GitHub itself directly of PyEnv. We just run this. We can see it's basically cloning the PyEnv repository in this particular location. Okay, and then we need to run some commands to make bash know that this is where PyEnv is. In our case, we are not using bash, we are using ZSH. So the command is Z profile. This will basically tell the shell whenever you will write PyEnv, this will tell the shell that this is where PyEnv is. Okay, let's now see is PyEnv installed or not. Okay, it is. We see that PyEnv is installed, and we see Python is obviously not. So what we do is we first see what are the various commands that PyEnv gives us. Okay, man. Okay, yeah, I haven't set the locale in this particular machine. Okay, let's just ignore that for now. I know the command, so let's just PyEnv install. Let's install the Python version 3.8.6. Okay, we see it through an error, and the error basically was, okay, we do not have a C compiler for now because this is a very new machine. There's nothing, so there is nothing. So we basically don't have a C compiler in it. So we'll first install that. Okay. So there are build essential tools that are required. Build essential is basically for building projects. It will install GCC and G++ and other libraries that might that would be required by them. So after that, you can actually compile it. Now let's get into this. Whenever you run into a error or something, just always Google, or you can also ask on GitHub. Because these problems are generally solved and like not worth being stuck to. Does anyone have any questions till now? Hey, am I audible?
Yes, Pradeep, you're audible.
Okay. Okay, so we see that it has failed again. Okay, let's just see the logs. Why this time this failed? So here we can see it's consider adding directly up. Okay, let's Google this. Okay, so there are some other tools that are required, which is OpenSSL libread. Even if you're not getting everything, that's all right, because like in the beginning, that is how things happen. And like just start doing it, choose a project you want to contribute to, web development related, and then just go. So the process basically goes always like this. If the project maybe has Docker in it, and they support local development using Docker, it does make things a little easier for you. But yeah, but it's always better to know things in more detail. What are the various services that are running behind? You might need to set up Redis as well and other things. Redis is basically a caching system that is used by uh, web projects, and you will need to separately add a database, set up a new database, add tables to it, run migration, run queries. So it's always better to do things in more detail in the beginning, so that like after some time you get used to it and you know what each and various command does. Okay, now let's try installing it again. And as you can see, you will always run into bugs. There would be something new, and it will always be there. Best thing I would say is read the logs. That is also a skill that is very much required in web development. always read the logs properly. Let it be console logs or the logs of the server, anything. Always read the logs properly. See the exact error, what the particular error is stating. See that error and then read it. Then just Google it. If you don't see that what particularly was missing, or you don't get it in the first read, just copy paste the error on Google. I think Prajwal already posted in the chats. Yes, he did. So, but yeah, it's always possible to run the software everywhere. Uh, it might be a little different. Like for example, Linux uses apt as the package manager. Windows for Windows you can use Chocolatey, and for Mac OS there is Brew. Yep, it's successfully installed now. Let's check the Python version here. And let's set it to global. So Python should also now point to this. Awesome. Okay, now we have Python 3.8.6 installed. Now what we can do is, so we were installing Poetry before, remember? Let's get back to that. Poetry, as I told earlier, it is used only to set up the virtual environment. You won't have to, you can, if you want, you can separately run the virtual environment commands, but Poetry just is a wrapper around those and makes your life a bit easier. You can simply make a Poetry file and then tell it what is the name of the environment that you wanted to set, and you can simply write. Now let's just see first of all if it's installed. Okay, Poetry is not okay. We also need to load the file again. Okay, awesome. As you can see, it's installed now. So these .profile, .z profiles, these files are basically used by Bash to know what where it has to find the particular program that you are writing. For example, if I write Git, it will look where exactly is Git, and the path variable specifically helps it to find that. So also whenever you might be installing something in Linux, you might have seen so many times you have to run export command where you are assigning path to something, and path basically concatenates that directory as well to its value. And whenever you type a command, path will search, okay, this is all the places where I have to search for the command, and I might find it somewhere here. And if you do not point it, it might just say that it's not found. For example, here we can see before it was basically not found. And what shows us, it basically reloads it. It reloads that you need to see if there are any new values. And it checks for the new value, and then just after that, it is able to find the particular Poetry. Okay, now we do Poetry install, and it will install it will make a virtual environment first of all. You can see creating virtual environment, and then it will install the dependencies. So whenever you are starting with a Python project, obviously there would be dependencies, not just Python, for say React, anything web development related or even not web development related. Project uses third-party libraries as well as might use inbuilt libraries. For inbuilt libraries, they are directly available. for third-party libraries. Can someone tell me what third-party libraries are? Okay, so basically third-party libraries are other kind of libraries that help the user in the particular language that are written by someone who is not developer of the language. Yeah, you can say that, but like if a Python developer can also actually write a third-party library. Third-party library are basically libraries that do not ship with the Python itself. For example, in Python's case, we will call a library a third-party library for Python in case it does not ship with the language itself. Okay, so there are libraries, there are frameworks that are made, and all the project that you run, they might be using one of those libraries, one of those frameworks. For example, Open Event Server uses Flask, so you will actually need to install Flask. Now what we can do is we can basically write pip install Flask, but nobody knows what the default version for Flask is at that time. For example, I started the project 1 year ago and someone else is contributing it in it after a year. When I write pip install Flask, it might give me the version 3.8.6. When someone else writes after 1 year, when they are starting to contribute in that, they when they write pip install Flask, they might be getting the version 2.8 something. So the project might not even run and it might show some errors. So this is where mm, mm, these environments are also useful. So for example, here you can see it installed those particular versions only. This version for this library, this version for this library, this version for this library, and things like that. And they were all specified in the log file. And this is how dependencies should be maintained and are maintained most of the times. So whenever you make a new project, you make a requirements.txt file maybe, or whatever virtual environment library you are using, they might give you their own format. For example, a log file or something else. And every time you update a dependency, you need to update it in requirements.txt as well, or your log file, and then commit it. So whenever someone else clones it or someone else updates locally, they see that okay, there has been an update in the log file or on the requirements file, and I need to update the libraries again. So say whenever someone simply updates, in our case, package.log, we just need to run this command again. It will see if any library has been updated or not. If not, it will just say, okay, nothing has been updated. See, no dependencies to install or update. Okay. Now to get inside that particular environment that was created, we write poetry shell. Okay, now we see we are inside this particular virtual environment. Okay, so now as we are inside this environment, now we have access to all these libraries and these particular versions of libraries which we wanted for our particular project. Okay, now let's start with Postgres. As like for backend, we use Postgres. Okay, so first of all, remember one of the commands that I ran that was azak something. Let me check. Yeah, this one. So we checked dap packages.txt and installed all the dependencies that were there. Okay, and Postgres was actually there. So if we simply check that Postgres is installed or not. Yeah, we see it's installed and it's active right now. Okay, so now let's create a new database. As we can see that in the official documentation of Fossasia Open Event Server as well, there are commands like for Linux user to set up the database. This is the first command. Now what it does is it basically creates a new Postgres user and gives our user actually the root privileges for Postgres. So we can easily create a new database or any other commands that we want to run. So now we are creating DB event, which is the name of the database that is being used by Open Event Server. And we created with the privileges of our user. Okay. We also create a OPIF test, and that is basically used for whenever you are running the test. For we have a separate test database as well. Okay. Now let's see. Let's go inside PSQL. Does anyone know what PSQL is?
Is it procedural SQL?
Yeah. So you can basically, it gives you a console as well, and you can just go into the console, and it's like a REPL of a language. You can write the commands and execute it line by line. Okay. So let's go into the PSQL and using the database O event and the user which is our own user, as it has the root privileges. We get inside it, we see, okay, we are inside PSQL. Okay, let's see what are the various tables that are available to us. Okay, there's nothing. Okay, there is a database, but there's no tables, nothing available here right now. Why? Because we haven't trained the migrations. Okay, now can someone tell me what are migrations? Database in terms of database. Yes, exactly. Thanks, Joseph. So they are basically table blueprints. Okay. So say you want to create a new database, you want to create a new table, and table and databases can go very long, very large. So how do I make sure that I have the exact copy or the exact table, columns, constraints, and relationships in my database as has been made in a particular project? Because say if there is one relationship that is skipping, it can just bring down the whole thing. You can get an error on a specific request whenever someone is trying to get a related information from another table, because that relation doesn't exist for you. So that's why migrations are used. Migrations are basically SQL commands, which if you will run in that particular order, they would basically simply make all the tables, all the constraints, all the relations that are originally made by the author. Okay, so say now I introduced some other column. Say we have a table users. Okay, now I decided that I also want to store a phone number of a user, or I want to give an option to the user to store its phone number as well. Okay, what would be the procedure for that? First of all, I will need a new row. Sorry, I will need a new column. That is phone number in the users table. Okay, I'll create a new column. I'll give it the particular constraint that I want to. Maybe I want to make it compulsory, then I won't allow null in that. Maybe I don't want to make it compulsory for every user, then I would allow null in that. Okay, maybe I don't want users to write country code alongside it, like +91 or anything else. So I won't allow, I would only allow numbers. Maybe I want to allow country code as well. Okay, so there are various things that you can do. So I make the column according to the decisions that are required for my particular use case. I make the column. That's the first thing. Now, whenever I make the column, I commit a new migration. Okay, I make a new migration that, okay, this is the column that was made by me. Okay, and the migration will have two things. There would be an upgrade command and there would be a downgrade command. I'll show you the upgrade and downgrade commands specifically in a little time. Okay, I think let's go to that now. Now, basically we have no relations for now in this. Okay, so let's run the migrations. For that, we actually already have a script ready. So you can simply create that script. Run that script, sorry. You can simply run that script. Okay, so it shows that it cannot find the env file. Okay, this is now something new. Okay, so there are environment variables. Can someone tell me what environment variables are? Okay, so there are various things, various secrets, or maybe an API key that you might need to store in the data in the project. Okay, and you obviously say you are testing out login through Facebook, for example, and you need an API key for Facebook. You are testing it locally, and you don't want to commit your API key, of course. Okay, so there is an example environment file first of all, and this is the file. This is the particular format, and these are the particular variables that should be used by the original environment file. Why do we make this and not directly .env? Because we don't want .env file every time to be committed, and we just ignore it. Okay, we ignore it for any user. Why? We don't want, if I say for example I add an API key for the Facebook in my .env, and then I do git commit or git add and git push, and every time my personal API key also gets committed. We don't want that for a particular user. So we just create this cat.env.example, which is an example environment file. We copy it to .env, which is our original env file. And now I can make any particular edits that I want for my particular use case in this file. So for example, I say in a project, for example, Open Event Server, we decided to change the name of the database itself. Okay, we decided that okay, O event is not that informative, and we should just rename the database as Open Event Server. So what would be done? Say I took that task, I started working on it, I locally renamed the database, and then for testing it out, I'll actually edit this file. And after that, to testing it locally. And if everything works, I'll also edit .env.example so that the default value at least is correct. And then commit it. And whenever I'll commit it, I won't commit .env. Okay, it would be ignored by itself. It's in git ignore. Okay, so now as .env is created and the default values actually looks good to me, we can just run createDB. And this time, hopefully, we won't get the environment error. Okay, now the super admin role. So whenever you are creating, so there are roles in a particular application. For example, in event A, there are many roles. There is an organizer of an event. There are co-organizers of an event. There are also attendees which are attending. There are simple users which are not attending an event, for example. Okay, and there are also admins and super admins. Admins which can create or delete any event or any event they are not even an organizer of. They can even say someone is trying to spam the platform. Someone makes a test event which is actually not being used. Okay, so an admin should have the right to delete that event. Okay, so admin has more rights. Then there are super admins. Super admins can configure API keys. We have everything in the front end, and the super admin can even configure API keys and many other settings, for example. Okay, so these are the rules. So while running createDB, we by default create a role for the super admin. We can just write an email, for example, say for us now, test@example.com is a super admin, and let the password be 123456789. Okay, now it is creating all the roles. It's creating services and every other tables. Okay, now let's go into PSQL and let's see if there is something new. Yes, there are so many tables now. Okay, let's go on to one of the tables. Let's see what users have, for example. Okay, this does not look good. Okay. So for the users table, these are the columns. There is related as, there is ID, there is email, password, Facebook ID, Facebook login hash, reset password, and this is the local database. So whenever, like, many times people say that I'm afraid to contribute to open source, I'm afraid I might make some mistake. You can never. You don't actually have the right. Even if you want to push a branch, you want to maliciously actually want to harm the organization, you cannot. Okay, not everyone has the right. You don't have the right to push to that particular repository. You don't have the right to the original database. This is all local. You can mess it up any much you want. You can just like go bullocks on this. You can mess it up anyhow, anyway. Just test it out. Test everything out. Delete something, make something new. You won't make anything or change anything in the original database. So you can just go bullocks and test everything out any way you want to. Okay. So there is also salt. So there is password hashing, there is salting, there is peppers and secrets and things like these. Let's not go into that maybe. Okay. So yeah, so the next command that I see is this one. Okay. I'm currently inside event. Yeah, so next command I see is this one. Now what this does. So for migrations, we particularly are using an ORM named SQL Alchemy. Okay, what is SQL Alchemy? Before that, what are ORMs? What are even ORMs? Okay, so these are tables. Okay, we make a table in a database and they run system wide. A database is a system wide thing. Like, and now I have the database O event on that particular Linux instance. I can't just make another O event. Okay, because I have that particular one. Okay, and now as I told migrations, now for writing migrations, I will actually have to write SQL. Okay, now say I'm a Python developer, I work on Python and I don't want to get into that. Also, migrations can get very messy. For example, say we added that phone number, right? Now we want to delete it. So what is the right way to delete something that has been done? Is there a way to undo things in database? There is not. You can't just make a simple .sql file. You write, create a column or some SQL query that you want to run. And if you simply delete that query and rerun that file, it won't work. It will throw an error. Okay, it won't work. It won't delete that column. You will actually have to write another query that will delete that column. So this way, editing, migrations and things like this, they can get very, very messy. So there are tools that even help in auto-generating those migrations. Okay, you can simply write the code in that particular language. For example, in case of Python, we use SQL Alchemy. SQL Alchemy and Alembic for auto-generating the migrations. So in SQL Alchemy, we basically write the tables. I'll maybe share an example table. We write in that particular language, and that from that language, we configure SQL Alchemy, and then we run the commands that we want to through Alembic, and it will auto-generate the migrations. So here it is. You can see this is the models file. We call that models as like we call these models for a particular table. A particular one table will have one model. Okay. So you can see this particular user model. Say if I want to remove this So there are, so say I decide that I don't want first name and last name to be separate. Okay, here it is. And I just want one column with name, and I want to delete this last name. So what will I do? I'll simply delete line number 66. The link I shared, you can see there. I will simply delete line number 66 and edit line number 65 to only have name. Okay, added whatever logic that is affected by it, and simply run the migration. And the command for that is python 3 manage.py db migrate. Okay, this command will look for changes in any of the models, and if it will find the changes, it will create a new migration file. Okay, you can see no changes in the schema detected because I haven't changed anything. Okay, so as I told, this will create a new migration. So migrations have upgrade and a concept of downgrade. So whenever you want to implement a change or someone implements a new migration and you want to upgrade your local database, you clone the code and you simply run python manage.py db upgrade. And if you want to undo that change, you simply run python manage.py db downgrade. Now it's that easy. If it was originally a SQL migration, you would be running query every time. Okay. And then there is this command to basically point to the head of the migration. Okay, this will point that this is the topest head. This is where the latest migration is. It will make a pointer to the latest migration. So whenever I will write python manage.py db upgrade, it will look for changes in respect to the latest head migration that was found here. Okay, so that way it knows that this is the latest migration and I have to work in respect to this migration. If I'll write upgrade, I have to go to the next migration that is after this, and if I have to downgrade, I'll go to the previous migration that is before this. Okay. Now everything is set up, though we also use Redis, but we don't have the time to set up Redis as well in other things. So we'll just run the server. Now let's see if the server runs. Yeah, it is. Okay, it's running on localhost 5000. Let's simply wget localhost 5000. See, it got a page, it downloaded it. Okay, so and you can see in the logs as well, it received a request and it responded with 200 code. So what is the 200 code? Does anyone know that? What does, if a request is 200 comes back with the status code of 200, what does that mean? Yeah, it was a successful request. There were no errors. So there is 500, which is for internal server error. There is 400, which are for authorization errors. There are 300s, which are for redirects and things like that. Okay, so there are error codes like this. 200 signify a good code. That okay, yeah, it worked. And it worked as expected as well. Okay, now I'll go to localhost 5000. I'll share another tab. Okay, can everyone see this? Yeah, so this is the documentation, the API documentation. Okay, so say I want to log in. Okay, so my basic URL would be I will have to send a post request on localhost 5000 /v1/auth/login and send these headers and a body like this. And if it would be correct, I will get a response code like this with the access token. Okay, say for example, I want events. Okay, I want to list all events. So there is, I'll send a GET request to localhost 5000 /v1/events. Okay, I'll add these things to it. Authorization and JWT token were the tokens that I get while making the post request to /v1/login. I'll copy paste that here. It is used to check that what role is of that particular user. Okay, what role, even like say I'm a normal user. Okay, obviously I won't want a normal user to be able to see all the events. Some events might be private, some might be public. Okay, so I'll check the authorization level of the user using this JWT token, and then I'll give the particular result. I'll throw a 400 error, maybe say you are not authorized to see this, or I'll return the results in form of JSON. Telling all the fields and about all the events. You can also request particular fields, sort the results. Like you can see there is sort and there is filter. We can also filter it. For example, say I only want the private events. So I can filter and like status is equals to private or whatever that particular field is called in our database. Okay. So this is what an API is. And JSON is a very simplistic data representation. So for example, in this case, this is what JSON is. Okay, there are sessions, there are social links. These are the related things that are related to an event. And this is the event itself. Okay, so you see JSON is simply a data format. There is also XML that was used before. And okay, with REST APIs, you can actually use anything in theory, but generally people prefer JSON. Now it is kind of in standard, but though it's not written anywhere. Like even with REST APIs, you can use anything else if you want to. Okay, but JSON is kind of the most popular one, you can say, for now. So that is how the API looked. Now let's get into front end. Now, does anyone has any issues or any questions, anything right now? Okay, so I'll stop sharing this and back to the terminal now. Okay, so Prajwal wants to know about Redis. So Redis is basically a caching system. So there are things that you actually don't want to permanently store in the database. Okay, but you also want it to be, say, sustainable for some time. You want it for 10 minutes, you want it for 20 minutes. So I'll tell you a particular use case. For example, say there are OTPs, right? There are OTPs through, there are also email OTPs. Okay, I'll send you a particular email link to verify your email and you will enter that OTP. Okay, now I actually don't need to store it for the lifetime, right? I need to store the user. I need to store the email of the user. The user exists and it will exist forever until user decides to delete that profile, even if someone the application provides that feature or not. That is something that has to be there for a lifetime. Though the particular OTP that might change. I might also have a feature to resend the OTP. And once the user is verified, I want the OTP to not be there as well. Okay, maybe I say that this OTP is valid for 10 minutes. You might have seen this thing. It's very common The OTP is only valid for 5 minutes, for 10 minutes. So I also want to delete that information. I don't want it to be existing over time or all the time. Okay, so this is one of the use case where Redis is used. Redis is basically a key pair caching system. So there are Python dictionaries, right? Python dictionaries. Okay, so Python dictionaries basically, they are kind of a hash map. They store a key and a key value pair. Okay, so I can store, say, uh, sorry, uh, I can store, say, user ID of a particular user and the token in Redis itself. And whenever a user sends request to verify that, I can simply pass it as a parameter. The link that I'm sending to the email, say I'll send this. Obviously, it won't be localhost, but I'm just telling. Okay, say I have a endpoint email / verify, and then as a parameter I'm passing tokens, which was 1 2 3 4 5 6. Okay, and the user clicks on this. Then it goes on to email verify and checks the parameter token, and then checks the token in the Reddit itself, and then deletes it after 10 minutes. So this is basically a caching system. There are some other things that you might require faster than just reading it on the database all the time. But also Redis is not used for things that needs to be sustained for the lifetime. It is used for temporary things. Okay. Yeah, Sheila, you raised your hand. Feel free to speak up if you have any question. Okay, you can also write it in the chat as well. Okay, now coming back to this. Now let's go back to Fossasia. Let's make this full screen. Okay. Now we need to git clone open event front end. Okay, obviously not like this. We need the link. So now I want the link, which basically is /open event front end. Now the same ideology here. I will clone the forked one first of all. Okay, and then after that, I'll set another remote upstream as we did earlier. So for now, let's just skip it and get right because not much time is left. Okay, so now, okay, so now we need to install yarn. Okay, for that, what we do is okay, again, this is simply from official yarn documentation, nothing else. So this basically adds the, say I write sudo apt-get install yarn. Okay, it might not directly be available in the official package manager. So for that, there are actually package repositories that you can add for installing third-party packages. So for example, for yarn, yarn is actually found here. Okay, so whenever you write sudo apt-get install in Linux, it actually goes into this, sees all the sources that are available, and sources are basically the repository that apt-get actually has to look into to find out where that particular package might be. Okay. Sudo apt-get update is required always after this to update that this new repository has been added. And now we can simply run sudo apt install yarn. Yes. And it will install Yarn. Yarn is the package manager. Like in Python, we have pip, though we didn't utilize it at all because we use the virtual environment and the wrappers around virtual environment. So we didn't need to interact with pip specifically, but we all know that pip is the package manager for Python. Similarly, for managing dependencies in JavaScript, we have Yarn. We have also npm, but I kind of choose personally Yarn over npm. Okay, now let's run yarn install. Okay, sorry. First of all, obviously I need to be inside open event front end. Now let's run yarn install. Okay, so we see that the default node version was node 10, but actually we need the version 12. So for that, uh, uh, as there was PyEnv for Python, we have something called NVM, Node Version Manager, which is used to manage the versions of Node here. Okay, so what we do is, again, the command is simply copied. We install NVM first of all. Okay, now let's see, is it installed or not? Not found. Okay, so there is another command that is written, which loads NVM. Okay. Okay. Okay, now we have NVM installed. So now let's install version 12 of Node. Okay, now let's check the Node version. We have 12. Awesome. We can also change the version specifically by simply writing nvm global. Okay, use, sorry, nvm. I confused it with the pyenv command. Nvm use 12. Okay, now using Node version 12. Now we can simply run yarn install again. Now that we are using Node 12, now you see it does not throw an error. It finds out that, okay, this is the particular version that you wanted, and this is the particular one that is installed as well. So it goes on to fetching the packages and installing them. Does anyone have any doubts till now? Or are there too many that you just thought to ignore it? Is it so? Okay, why yarn over npm? Personally, the logs are much cleaner for me. First of all, yarn logs are much cleaner than npm ones. Secondly, I think yarn is also kind of faster whenever I use yarn. So that's the use case for me. Though there are multiple debates on the internet on this yarn versus npm. So just, yeah, make sure whenever you are bored and want to see two people fighting, just start a conversation on this, or just go to the internet and see results for this. In front end's case, things would be very much cleaner and smooth, because obviously we are not for backend and the API, things were very much messed up. There are multiple things that we are using. We had to set up a database, and we actually had to set up Redis and everything as well. Though for now we are just ignoring that, so we won't be able to use some of the other things uh, which we might have used. For example, we use ticket generation. For that, there are PDF generation. For that, we use Celery asynchronous task. So we also had to set up a Celery. So we don't have so much time right now that we can set up all that up. But for now, for minimum functionality, these are the basic steps. Okay, I see all the dependencies are installed now. So, okay. Let's copy the environment variable. Now, as I told that, now this will need an API link, right? It's just the front end. It doesn't have API. Okay, this will need an API link to interact with. So, oh my bad. So for now, it uses the official test link of the Open Event server. But in our case, as we have the API running locally, let's just do it at localhost 5000. Okay. And we also need to generate internationalization text. So the thing is that for making an application international that is supporting various languages, there are always translations that need to be done. Okay, and this command basically generates those translations, you can say, for now. Okay, now let's start the server. Now we know that this server would actually be, this front end would actually be using this server. It's building right now. In the meantime, if anyone has any questions, feel free to ask. We can ignore these errors for now. Basically, these are not errors, they are more of warnings. And you will always find a lot of them in JavaScript. Okay, it's just starting up. The setup is done. We just are waiting for the build to complete. I'll just share a Chrome tab now where I can show you the, yeah. So it's simply localhost 4200. This is where the front end is running. So remember, we also created a super user. So let's just log in through that. s@example.com, because it's using the same API, right? It's using the local API. Okay, invalid credentials 3, 4, 5, 6, 7, 8, 9. Yeah. Yep, we see that we are now logged in. We haven't created any events, so there are no upcoming events. You can create an event. You can go onto the admin panel and see the various settings, and this is all local. So you don't need to worry about messing anything up. Okay, so the time is up. I guess that's all for now.
Yeah, Pradeep, maybe quickly we can go through maybe one or two questions from the audience.
Yeah, sure.
Any questions from the audience, particularly about the Event A platform? You can also drop your questions through the chat window. So Pradeep, one quick question. How long have you been associated with Fossasia?
Okay, so I started contributing when I was in first year of college, and since then, for 2 years, I was very much into that project and contributed very, you can say, continuously and very frequently. Then the last 2 years were a little busy for me, so there was a lot of like I just helped in reviewing the PRs and all. So almost 4 years now, I would say. Yeah.
Yeah, thanks, Pradeep. So I hope we don't have any further questions from the participants. So yeah, so thank you, Pradeep. It was really great to have you. Thank you for that wonderful session on web development using Python Flask and especially introducing it to the Event A platform. It was great to have you. So a big thanks from the entire team of Open Source Summit 2021.
Sure. Thanks, Jacob.
Yeah. Yungbin, I hope you can hear me.
Hello, Jacob. Can you hear me?
Yeah, I can hear you, but I think your video is off.
So do I
Yeah,
just need to?
Yeah, we can
right?
see you now. Yeah, we can
Okay.
we can see you now. So Jaren, you're here. Jaren.
Yes, sir. Yes, I'm here.
Yeah, Jaren, we can start. Yeah.
Okay. So welcome back, everyone. Now it's time for our next session. We have with us Mr. Yungbin Han, DevOps engineer at CloudMate. He is the organizer of Ubuntu Korea and UbuCon Asia 2021. His interests are in Golang, web development, DevOps, cloud computing, Linux, localization, and open source. To make it more clear, he is one of the Ubuntu enthusiasts who've been organizing the local Ubuntu community in South Korea for many years. I welcome you, sir, for the session on Git for Beginners to collaborate on team projects and open source. Over to you, sir.
Hello, everyone. Thank you, Joanne. So today on this my workshop session, I would like to some introduction about how to use Git to manage your source code, and also to how to use it for collaborating with other people and like participating in open source. So let me share my screen. Just a moment. So for my session, I prepared the Notion document rather than the PDF or slide, so that you can see the document and try out. I'm gonna share this link to Notion in the chat room. Where do we find the? Okay. So can you guys see the link URL to the Notion? And you can go to the link and you can take a look at the same document there. You will see the document through this workshop, and if you want, you can. It's actually made to written to. You can easily follow and you can easily try.
so you can easily learn how to use Git on this workshop. So the Jaren already introduced me a bit, so I'd like to just pass the my introduction. So let's get started with the why use Git. So about the installing Git and OpenSSH, I already tell Jacob that attendees will need to install the Git and SSH on their machine to begin, because it usually installs some many times to download the installer and install it. So if you don't have installed the Git or SSH yet, you can see this guideline to learn how to install. So let's get started with the why we need to use Git. So let's talk about some traditional way of some collaboration with your friends. Like, let's say we have you're in the kind of class in the university or college, and your professor gives you a team or group assignment. So, and then you need to each group will need to give their own presentation at the end of the semester. So basically, you need to work on the same document or presentation document with your friend to collaborate on that. So in very traditional way of that, and like let's say you're gonna work on some like chapter 1, and your friend will gonna work on chapter 2, and what you're gonna do on the last, you're gonna collect each 2 files and merge that into a single file, single presentation, and you're gonna do it manually. So if you do that in that way, so this is what will gonna happen on your chat room or email. So you just basically need to share a lot of version of your file, and whenever you have some updates or modification on the file, so that you can update and keep it latest before giving presentation. But nowadays, people use Google Docs or Google Drives or some other Office programs that supports the version control feature, or something like real-time collaboration. You can, if you just edit the document right there, and it automatically tracks the version of your document. And if you want, you can feel free to switch back to previous version of your document. So if you use this, you don't really need to like share multiple files like multiple times, because the program manages the version for you, and also something like sharing the documents. So in the same context, when you're working, let's say now you're gonna working on a software project, you're gonna write a simple program with your friend or colleagues to build a single program. So if we don't have something like Git or other version control system, you basically need to do the same thing like you saw before here. You need to create the multiple version, and whenever you need to get the updated file of your friend, they will need to send the file every time, and you need to merge that manually. So, and also to avoid for the backup, you also need some other versions like this. And so in that way, you need to to managing version everything manually by your hand. So to do this a bit more better way, we now have a version control system, or VCS for short. It's like pretty much similar. It does the pretty much similar job as what you can see on the Google Docs or other offices that comes with the version management. And like the history feature on your Google Docs, and it also keeps the history so that you can see what was the previous version, how does the previous version of this code look like. And you also you no longer need to manage the version of each source code manually by just making the multiple copy of your code. So it also helps you to avoid mistakes when you're managing multi-version. So this is basically what you can see on the GitHub. I think if you saw the event.js session on the right before me, you will also see this kind of screen on GitHub. So for example, let's take a look at the our website source code for the UbuCon Asia 2021. And if you look at click the commits, here you can see the every history of this repository. If you click this, you can see what was changed on this commit. So because the Git manages everything, like basically for the managed version for you, it will be a lot easier to manage version. So when it comes to version control system, there are actually many kinds of these version control tools, not just Git. There are also something like SVN or something. Or I think I remember there's a very old HH system, CSV, I guess. And so there's a lot of many different version control systems. So when it comes to version control system, there are usually two kinds of the system. One is the centralized version. It has a central version control server that keeps the version database, like you see here. Like you see here, this kind of version control version database exists on the server, and on your computer, you simply just check out the latest version from the server. The centralized version you haven't used widely before until the distribute version, something like Git rises. It's like this is actually what like Google Docs looks like. They have the every version database and there's on their own server, and each users they will need to access the Google Docs with the web browser to look at the documents contents and the history. But when we are using the centralized version control system, there has some downsides of the system. So let's say when the VCS server accidentally goes down, and because the version database only exists on the server, if the server gone, you cannot do anything with the managed history, or you cannot also publish new version of your code, and you can also check out the latest version or some previous version to see how was the code look like. So in conclusion, when the VCS server down, in the central VCS server, your team won't be able to continue collaborating on the code. So this is why distributed version of the VCS pops in. So let's look at this photo. So difference, you can now see there's some difference between the centralized version and the distributed version. So the big difference now, what's that the big difference is here? You now have the version databases, not just on the server. It also, the same database is also fixed on your local computer, so that you can see the database or version history even when the server is down, and even when you're offline, when you're not connected to the internet, so that you can quickly update. So that you can just, if you want to see some previous version of the history, you can just simply check out to the so your desired version, even the server down or you're disconnected, because the database also now exists on your computer. So that's why many people are now using Git or what rather than SVN, like centralized version. And you can see the like you can see the GitHub. Git is like most widely used version control system. So if you would like to collaborate with your friend or colleagues to work on the same project, Git will be a great solution to manage version or collaborate and track updates. So since we learned why we use Git and some introduction to version control system, let's continue to creating our first commit on our local repository. Wait a moment. So before continue to create a local repository, we first need to configure our some information that will be included on the commits. Commits are basically a snapshot of your code, or it can be also history of the code. So to configure your basic information, you will need to use git config command line, and with the global option to configure your personal information. You will need to configure your email, like this, and your name, to review the configuration, you can use the git config -l to see the current configuration. So here, we now configure our name and email here. So since we configure our basic information, we're now ready to create our new repository. So to create your own repository, we first need to create a new directory here. In most operating systems, you can use mkdir. to create a new directory. I'm gonna create with the name Git workshop, and you can use cd to enter the your desired directory. If you want to see what's inside the current directory, you can use ls command to see that. If you're using the command line prompts on your Windows, you need to use dir instead. So since we just created our this directory, the directory is empty. So in this empty directory, let's initialize a new local repository. To initialize, you just simply need to git init init to initialize our repository. So now it says, well, it shows in Korean, but you can see that it says they have initialized an empty repository. So after that, we're gonna create some files there for examples. We're gonna add a simple markdown file and also a simple HTTP server written in Python. In this case, I'm just gonna copy and paste those codes to my directory. So you're on your Git workshop and the file with the really.markdown. And an example Python server code here. Also add that as my server. So we just said, since we added some two files to use for examples, and we're now gonna create a commit with the two files. But before creating a commit, if you look inside the directory, you can actually see there's of course there's a README and my server, but there's also this directory, .git directory. This directory actually holds every information of the repository and some commit data and history data. And also, if you add the information about the remote repository, that will be also stored inside here. So let's talk about what happens if we create a commit first. So there are usually, when it comes to creating a commit, there are usually three different areas for the working with the flow. There is a working directory. This is where you actually work with your source code, or you add your source code you write here. And if you want to add that commit that create the files as a new commit, you will need to add files on the staging area. Staging area is like it's for preparing for your commit. It's for deciding which kind to include on the snapshot. And finally, if you actually create a commit, it will be moved to repository. And this is where the history data or commits of your repository is stored. So to get started with adding a commit, we first need to add our 2 files onto staging area. To do that, we're going to use git add and your file names. If you want to add some multiple files at once, you can also use git add and that. But I would like to it is usually not recommended for you usually, because if you have a lot of files that has been updated in your local repository, if you use this, you might accidentally also add the files that is actually unnecessary for your commit. So it is recommended to specify which file to add. We also add readme.md. So to check if 2 files actually added on the staging area, we're going to use git status. Then it will show you you're in the current branch master. You don't have any commits yet. And changes to be committed here. So you can see there says new files have been added to the staging area. So after adding your files to the staging area, you can now run a git commit command line to actually create them as a snapshot or a commit. If you simply run the git commit, it will open up a text editor with some instruction for creating a commit. It tells you that you need to add a commit message without the hashtag on the starting of the line, and you see the list of the file that will be included on your new commit. So we're gonna put our commit message here for this commit. Let's say simply first commit, and you just need to save and close the text editor. So now you can see the commit has been created. If you want to confirm that commit has been created, you can use the git log command line. It will show you the list of the commits that you have been created. Because we only created single commit, it currently shows only one. But as you continue to work on the code or your repository, it will start to show you multiple and every history of your repository. So there you just have created your own first commit, but on your local repository. So, but this repository currently exists on your local, just only on your computer. If you would like to collaborate with your friends, you will need to publish your code somewhere, something like GitHub. So let's move on to our next step. On the next step, you're gonna learn how to publish your local repository onto the remote. remote is basically the every repository on the internet, like what you're gonna create on the GitHub is also a kind of remote repository. So we're gonna use the GitHub to create our own new repository. And let's get started with creating new one. Well, if you log into the GitHub, you can see the new button here. And also on the top right corner, you can see the plus button here. If you click this, it will show you a shortcut to creating new things. And there you'll be able to find new repository button here. So let's create a new repository here. We're gonna use the Git workshop. And we're gonna just make empty description. And you can actually also set it to private, but for the education purpose, I'm gonna configure it as a public repository so that you might be able to see the repository after the workshop, or you can also see it now. So you now have your own remote repository. Now let's try to push some commit to there. So before pushing some commits to the repository, so you know that this is actually a Git and also SSH workshop. We're gonna talk about, you also learned about how to authenticate to GitHub with the SSH key. In order to do that, you will first need to create your new SSH key. So what is SSH actually? It's also called secure shell. It's basically a protocol or a software used to make a remote connection with the server and your computer so that you can remotely manage or control the server from wherever you are. And it also provides a secure connection with the encrypted connection. So let's get started with the creating a new SSH key. You will first need to move inside your home directory, and on your Linux or Unix system, you can simply cd and tilde to move to home directory. On the home, wait a moment. On the home directory, there's usually a .ssh folder where this directory stores some information for your SSH key and some connection info to the remote server. So you're going to enter this .ssh directory. So you can see some SSH key pairs that I have previously created, and some known host. This includes some information to the remote servers. I'm going to remove the GitHub key pair and create the same one. So to create a new SSH key, you can use SSH-keygen to create new one. And it tells you to provide a name for the key file. I'm gonna simply use GitHub, and it also tells me to enter passphrase, password. And if you don't want to enter, you don't need to. In this case, I'm gonna skip entering password and also pass. And there we are. We have just created our own SSH key. There we are. And we're gonna authenticate to GitHub with this key. The SSH key is basically our key pair, which has a public key and a private key. Like the literally public key is it's a key that you share with your friend or publish online publicly so that other people can take a look at it and know about your information. And also, of course, private key. Literally, you keep it private and use it to authenticate that to prove yourself. And of course, you don't share with your other people with this. So to authenticate on GitHub with SSH, you first need to publish the public key on your GitHub account, so the GitHub knows about your knows what kind of SSH key you're using. So in order to add your key, you need to move on to your GitHub settings. Can be found here. And there you will find SSH and GPG keys menu. You enter there. I'm going to delete this key that I previously added. And you click the new SSH key. You will see the submission form for registering your SSH key. So here you will need to put the contents of the public key. So we have the two files here. One is GitHub. This one is the private key, and another one, this one, github.pub. This is the public key. Let's see the contents of this key. And it looks like this. You simply copy and paste into GitHub here. And some proper name to where this key is located. In my case, I'm using key on my MacBook Pro. So I'm gonna put MacBook Pro for the title and click the add SSH key. So after adding the key, so since we have added a key, before using the key, let's check if the authenticating with the GitHub works well. Before that, you also need to register the private key into your local machine. To do that, you can use the SSH add command and your private key as an argument. So that will add the identity to your SSH client on your local machine. So we can now test the connection with the GitHub. To test the connection, you can use the SSH-t command to test it. And for the address, git@github.com. Right, this is github.com. If you enter this, if you haven't tried to connect to the GitHub with the SSH before, it will actually show you a dialog to that. Do you trust this GitHub, this remote server? So you need to say yes that you trust the server, and that after that, if you see that it says it greet you with a simple sentence like hi Yongbin or hi SUK 96100, it means you're successfully authenticated with your SSH key, so that you can now use this key to publish some commits to your remote repository. So we can now publish some commits there. Let's continue to moving back to our repository on GitHub. If you go to the, if you move back to there, you can it actually shows you some quick instructions to push some commit to remote repository. So on the top, you will see the URL to your remote repository, and you can choose the protocol for your URL. It supports HTTPS and SSH, but since we're gonna use SSH, we're gonna choose this one, and we're gonna copy this address with this button. So in order to push commit to our remote repository, you'll need to let our local repository know where the remote repository is. To do that, we're going to use git remote command and with add option and an alias or like short name for the repository address. And then on the left, you put your URL to your repository. So this command basically means this we're gonna add this URL as the name origin. Origin is actually a kind of default name for the repository remote name. Oh, I actually on the wrong directory. I need to move back to the repository. Okay. So let's try again. So we have added the repository information. To confirm that it was added, you can use the get URL origin to see the actual URL that has been added to your local repository. So since we now have confirmed that we have added information about the remote repository, we can now push commit to there. To push your first commit, you're gonna use git push, simply git push. And you also need to let the local repository know that what kind of which remote repository you choose to you're gonna where you're gonna push your commit and which branch you're gonna push. So for the remote repository, we're gonna push our commits to remote called origin, and we're gonna push master branch. Master branch is a default name for the default name of the branch when you create a new repository. And you also add set upstream option, so that you don't need to specify the remote name and the branch name every time when you're pushing commits to remote. So that's been pushed to our remote. Let's take a look at our repository on GitHub. Let's click the refresh button. So there we are. We have the 2 files published on our GitHub. And you also see the commit data, commit information here. Let's take a look at the details of this commit. And for this commit, this includes the contents for the myserver.py and readme.md. So you have published your first commit on your new repository on your GitHub. So now we have push to the commit, push our commit to repository. But if you would like to collaborate with some with your friend or other people, you actually need to have some separate spaces for working your code, because if you don't work on the separate space, when you're pushing or pulling commits from the remote repository, it might the contents might conflict. There could be conflict, especially if multiple people work on the same file. So if the file conflicts, it will look like this. To avoid this kind of situation, we can use the branch feature. So branch is basically it's a pointer that points to the specific commit history. So like this photo, you can see in this photo we have the 2 branch here. We have master, which is a default branch, and we also have a testing branch. The only difference between this is just points to the different commit, so that you can switch between branch easily, and then you can see the different section and can work on the separate space. So before creating our new branch on our local repository, and I think maybe if we have some couple of more commits, it would be better to understand if we visualize our commit history of our Git repository. So for example, I'm gonna create a new text file here and simply add a hello world to that and create a commit. So create a new text file here. You're gonna put some contents here. There we have our text file, and we're gonna add that onto our staging area. And create a new comic. And let's also push the commits to our remote repository. Since we have already since we used the set upstream option last time, we don't need to specify the remote and branch information this time. We just need to run git push, then it will push your commit to the origin remote. So you can now see the hello text has been published on our remote repository. Now let's create a new branch. To create a branch, you can just simply use the git branch and your desired name of the branch. So in this workshop, we're gonna create a branch named testing. Let's create it. Git branch testing. And to see the list of the existing branches on your local, just simply type git branch, and then it will show list of the branches on your local. But you can see that we're still using the master branch. We need to switch to the testing branch. To do that, simply just use switch testing. Then it says you're now switching to the testing branch. So let's take a look at the how does the history look like when we create multiple branch. To do that, we're gonna use git log with the grep option. If you use the grep, it will also show you a line between your histories so that you can easily understand some the relations between the every commits. You can also add the all option so that you can see the history for the every branch. So if you look at here, we have 2 commits here, and this means that you're on the you're watching this this snapshot currently, and it says there's there's 2 branches here that points to the same commit. You can see the testing and master. They're pointing to the same commit, this one. So let's actually to see how branches work, we're gonna add a couple more commits to each branches, but with the different contents. To do that, let's simply switch between 2 branches and update each files, update the same files, and commit changes to each branch. So we're on the testing branch on here, we're gonna add here text from testing branch. And we're gonna switch to the main branch. No, master branch. And we also add some more contents there. Oh, I actually forgot to make a comment with the changes. So let's try again. We create a commit here. And let's switch to the master branch. And we also commit the changes of master branch from the master branch. By the way, if you have any question regarding the workshop, you can feel free to leave comments on the Zoom chat room. Let's continue to add some more comments. So there we are. We created 2 commits on each branches. So let's look at this text file on the right side and how does the content changes when we're switching our branch. So we are currently on the master branch. So because of that, it shows the text here like this, text from master branch. And let's try to switch to the testing branch. And since we switch to the testing branch, that points to the latest commit on the testing branch. You can see the different contents here. It now shows you the text from testing branch. Let's also take a look at the some visualized version of the git log again. We're going to use the same command, graph all. So you can see the branches. You can see the drawings, some lines are a bit different from before. It now shows you that the 2 lines have been diverged from this point, this commit, which is the message is add hello.txt, and it has been diverged into 2 commits. There are now different contents and different history. One is diverged into the update hello text from testing branch, and the other one has been diverged into master branch, update hello text from master branch. So with by using the branch feature, you can manage the you can actually work on the multiple tasks. So let's say if you need to work on the some implementing a new feature, and you also need to fix some bugs at the same time, then you can use the multiple branch on your local repository, and whenever you're working on the different task, you can switch over to the corresponding branch for specific task. So we can have a branch like for this case we're using the name testing. We can instead have a branch named something like new feature, and also something like bug fixes. And then when you're working on the implementing new feature, you can switch to the new feature branch and then work it. And if you need to work on the bug fixes, you can just simply switch back to the bug fix branch. And if you need to see the latest code that other people working on, you simply need to work on the default branch, which is master, or it is also some repository also use the name main instead. So yeah, you can easily switch between branches to work on some different tasks. So so now we have created some updates our branches. So after if you done working on your branch, let's say we've completed working on some implementing new feature on the like new feature branch. So after that, it should be the changes need to be merged into default branch, so that it can be on so that users can use the new feature on the final product. So in order to do that, we're gonna merge the testing branch into the master branch. So since we're gonna merge the testing to the master, we first need to switch back to the master. And okay, switch master. And then we're gonna merge the testing branch into the master. You can simply use git merge testing. That should bring the commits from the testing, but you can see that it has failed to automatically merge testing into the master, because this is because we have worked on the same file and the same parts on the of the file, but from the different branch. So if you look at the right side on the text editor, you can now see that some weird mark is out here. So it has to manually merge the conflicted part. So you can choose between 3 ways. You can choose updates from the current branch. You can actually see that there's a text. It says head. Head means that your current branch that you're watching, and this is from the your current branch, which is master. And as you can see, this content is from the testing branch. So if you want to if you want to decide to choose only just updates from the master branch, you can only just leave this line and remove the other lines. If you want testing, you can just leave only this line and you just simply remove the other. If you want to have both updates, you simply just remove these marks. In this case, we're gonna have both updates for the both branch. So we're gonna simply remove this mark here. And we have manually fix the merge completes. Since the merge has been failed here, the merging has not been completed yet. So to complete merging, you need to first we already fixed the file, and you need to add this file onto the staging area, and we just simply run a git commit command line to complete our commit. And git commit. If you run the git commit, you can see some difference from before. It now has the commit message that has been already entered here. And it also shows you the files has been conflicted before, and you can confirm the result file that you have fixed. And after confirmed, well, same way, you just need to close the editor, save and close the editor to complete merging your branch. So that we're gonna create a new commit for merging your branch. Let's have a look at the git log command line output again. And you can now see some difference here. So from the first commit, second, and from the second, the commits have been diverged into two branches here. One for the testing, one for the master. And you can now see the two lines. After that, we have merged two branches into one, so that you can also see that those two lines also merges into a single line at the last. So we now also try to work on we now also learned about how to use branch to work on some multiple tasks and avoid conflict with other people's work. But this branch still remains on our local branch. We need to publish to our remote repository so that people can see that what you're working on. So for the last step, we're gonna use the pull request feature and some issue tracker feature on the GitHub. These features are very widely used among the many open source projects, And also when you're also having some personal projects or like team projects for some your college assessments, by using the issue tracker and pull request, you can easily track track each people task or something like bug tracking or feature request. Let's have a look at the issue tracker and how does it look. So issue tracker actually can be found on your repository page on the GitHub. You'll find the issues tab here. Well, since it's an empty repository, it doesn't have any issues yet. You can also look at some other repository to how those issues look. Let's look at this repository, for example. So you can see the some issues that open here. You can see some issues or something for discussion for the some asking questions or some bug report. Just like these people, this person says they installed the software and it's not working. And people usually then people can discuss about this topic on this issue. If you look at some other status messages other than the comments that people added, you can also see the other action, track the other actions. Something like someone added a new label or someone added a new commit regarding this issue. So you can also track everything regarding this single issue. You can easily track what's going on about this issue. So let's start to create a new issue. For example, here, you can find the new issue button here. Click it. For this issue, let's say we'll have a task for submitting a new pull request. And some descriptions for the issue. And you can also add some more detailed information on the right side. You can set assignees who you're gonna handle this issue. For this case, let's say, are we gonna handle this issue? So you can just simply click assign yourself here. Or if you want to choose other assignees, you can click the gear icon and find some other people here. And you can also use labels to categorize your issues into some few groups. There are some ready to use some labels like bug, documentation, duplicate, enhancements, good first issue, like many things you can use right away. For this case, let's try to use the good first issue because it's actually submitting a simple request is easy to try. And let's submit a new issue. So we have created a new issue. And now let's look at how we can track the status with this issue. You can actually reference this issue you just have created on your commit message. To do that, you just simply need to put an issue number with the hashtag like this. For example, this issue has the number 1 issue. And you just simply need to put hashtag 1 on your commit message. You just need to include it. So let's try it and see how it works. We're gonna create another new branch here. In this case, we're gonna use the checkout and -b. This we're gonna create new branch and also switch to the new branch at the same time. The branch name will be simply PL. It's a short for the pull request. And we switch into this branch. And let's add some more content of the hello.txt. Maybe we can also use the readme.md here. Let's try to commit this updated readme.md instead and add readme and also commit. And on the end, you just simply need to put hashtag 1 to reference issue on your commit. But you can also wrap with the some braces. Then let's commit. And you're gonna push into remote repository. Since our remote repository doesn't have the PL branch yet, we first need to publish the branch. You can simply do that by specifying the remote and branch. It's same as before when you're pushing your first commit. So let's now look at our remote repository here. You can see it has PR branch has some recent updates a minute ago. And if you click this button here, you can now see that the PR branch is also on your remote repository. Let's click the PR to switch into the PR branch. And you can now see the more text that I just added before. And let's also look at the issue that we have been created. Here, issue number 1, submit a new pull request. And you can see that our commit that has referred this issue that now also appears in this issue page. So you can basically track everything regarding this issue simply here, and also you can also track discussions here. So since we have tried to work with some issues, we now have to let's try to open a pull request for the next step. So previously, to merge what we have worked on different branch, we manually merge 2 branches on our local machine. But instead of that, let's try to merge on the online on GitHub using the pull request, and we can also review the some changes before merging the pull request. Before continuing to creating a pull request, do you know that there's actually some specific keywords that can close the issue automatically when you merge the pull request? Like for example, if you look at our commit log, okay. So we to reference our issues here, we use the sharp #1 here. You can actually put close this #1 so that it will automatically close the issue with this number when people merge, when some other person merges the pull request into default branch. So to demonstrate how it works, let's also try to add another commit. We're gonna update hello.txt again. Simply just some more text. And on the end of the commit message, we're going to put close this #1. So let's try to push another commit. Okay. So now that we push some commits that we're gonna include on our pull request, so it's time to create a new pull request on our branch so that we can merge the pure branch to our default branch. The pull request menu can be also found on here. It's next to the issues tab. You can simply start by clicking new pull request here. So now we have some page for the creating and reviewing your pull request. You first need to choose what kind of branches you would like to merge. So we're gonna merge test PR branch into the master branch. So you're gonna choose PR here, and for the base, just leave it as master. And you review the some commits that will be included on your pull request. if you think it's right, it is okay. And it equals the proper commits to be included in the pull request. And if you also think the changes appears here, it's also okay. You can continue creating your pull request. So if you look at the opening pull request form, this is actually similar to creating a new issue. The difference is that you just need to you're gonna put the description about the what has been changed about these commits. So for this pull request, let's just simply put title for the pull request assignment. You can also choose you can choose some assignees and labels. But if you're opening pull request to contribute to some other open source projects, this is usually chosen by the maintainer of the project, also for the reviews. So now let's try to create a new pull request here. Create pull request. So we now have our first pull request created here. You can review what has been changed on the pull request and what kind of comments are included here. And you can see the changes of the files at a glance. So now that we have opened our new pull request, to merge this pull request onto our default branch, or if the pull request is from some other repository, you will need to review the pull request before merging it into your branch. So reviewing pull request you do on the same page. There are actually some useful tools for reviewing pull requests. You can add some comments directly to the specific part of the code. For example, let's add a comment here. If you hover on the code, you can actually see the blue plus button on the starting of the line. If you click it, you can now add some comments about this line. You can also, if you want to suggest some another code, you can use this plus minus button so that you can suggest another code to the pull request submitter. Let's, for example, you can suggest to put welcome here. And if you click and some comments, and if you click the preview button, this will show how will your comment look like. And if you're done adding comments, you can click either cancel or edit single comments or start a review. For these cases, let's start the review and add some more comments. And here, you can also add some more suggestions here. And add another review comment. And when you're done reviewing the pull request, you can suggest you can submit the final review for the request. Unfortunately, since I'm trying to approve my own request, since GitHub doesn't allow to do that. Instead, I'll try to just add a comment and submit review. Then it will also show that what you have commented on the specific line, also on the conversation view. And on the conversation view, you can also directly you can also decide to directly use these changes on your pull request. You can just simply do that by clicking commit suggestion and here commit changes. And that will add updates. That will add another update for that suggestion. And let's also try to update this file with this suggestion. And you can now see that both suggestions have been applied to our pull request. You see that there's now some more words that have been added to here and here. Finally, after reviewing the pull request, you can decide to whether you're gonna accept the pull request by merging it, or you can also reject the pull request. If you want to reject the pull request, you can just simply close the pull request. But if you want to accept, you simply click this big green button here, merge pull request. Let's confirm merge. Okay. So now we have created our first pull request on GitHub, and we also reviewed our pull request, and finally we have merged our pull request. After merging the pull request, you can see that every other commits that has been only available on the PR branch can be now seen on the master branch because it has been merged into the master branch. So using these ways, you can collaborate with your friends or some other colleagues to work on some team projects when you're working on a single software. You can also manage the multiple version of your software easily, and you can work on the multiple tasks by using branch. And we also learn how to authenticate with the SSH key. You actually see that we haven't typed any password for the GitHub when you're pushing commits to the GitHub. Actually, when we use the HTTPS URL for pushing commit, you need to enter your password at least once, so that you can authenticate with the GitHub and push your commit. But with your SSH key, you don't need to enter. You don't need to enter password when you're pushing or pulling some commits from the remote. And we also learned how to use issue trackers, and pull requests. This is a very basic usage, basic guideline for that. And I think with these guidelines, you will be able to work on some team projects or submitting pull requests. There are actually more articles or other websites that you can take a look at, so that you can learn further. Like the official Git documentation. If you visit, you can see a kind of book or reference manual here. Or basic, you have also some videos. Do you know that there are also some strategies or workflow strategies for managing branches? You can also take a look at these articles to learn about how to manage branches in a specific way. When it comes to managing branches, managing branch with a specific model, there are also various ways to manage your branch. Some of the most widely used was Git flow model. And the Git flow models, the branches look like this. You basically have some 2 or 3 more branches for some specific purpose. And there are also some simple branch models like GitHub flow and GitLab flow. And you can choose the branch managing model that fits your needs. I think the Git flow model could be a bit complicated if you're new to Git. I think maybe GitHub flow or Git flow. Something like this. Just use only a couple of branches to manage your task. This might be better for you when you're first starting your own project. Oh, so that's all for the for Git workshop. And I think as the Jarin introduced that interested before I'm starting the workshop. I'm also organizing the first Ubuntu Asia conference. We're still looking for some speakers and some attendees. If you're interested to join or submit a session proposal, you can head over to our website and have a look at some details for the something sessions. So that's all for the our Git and GitHub and SSH workshop. Thank you for attending the workshop. Thank you. Does anyone have any questions?
Thank you, Yungbin. Participants, if you have any questions, you can ask in the chat box. Yungbin, we have one question. Yeah, will the material you provided be there for future reference? So I hope you'll be sharing that with the participants.
I already showed the link to the material.
Yeah.
The Notion link. Can you take a look at the link if you can see the material?
Yeah.
I will also share on the Telegram group, so that other people can also see the.
Yeah, sure. Okay. So, do we have any questions from the participants? You can directly ask Yungbin. Yeah, Yungbin, it has been a great session. I know that you're joining from the late hours. It's almost 8 p.m. there at Seoul, your time. Thank you so much for being part of Open Source Summit India 2021. Looking forward to collaborating with you on future events also. Thank you. Take care. Bye.
Thank you.
And for the participants, we have got some exciting sessions coming up tomorrow. Mostly we'll be having the IoT and Linux security tracks. So we'll be having a keynote session by Django Isidorovic, then session by Sayan Chowdhury on Linux Flatcar container, and by Akshay M on Riot OS, and practical web application hacking with Kali Linux by Harsh Akshit, who is a Google Hall of Fame. So that will be the afternoon session. If you haven't yet joined the Telegram group of the summit, please feel free to join. We have already shared you the email invitation. Also, you can follow the summit event on LinkedIn and the Open Source Club page on LinkedIn. So thank you so much for attending today's session. We'll see you back tomorrow. Bye. Take care. And the feedback link is also shared. Thank you.